Yep. Alright, guys, I need tissues. This is getting out of hand. I gotta run to the house real quick. I'll be right back. So, yeah, we gotta switch over from hearts to science and technology. And then we have to Firefly Alpha attempt. Firefly Alpha, yes, flight to launch coverage. Yeah, Curl, I'm gonna go get a, yeah, I'm gonna go make some hot chocolate, dude. I'll be back in a moment, fellas. I'm back. And I brought snacks. Ugh. Okay.
Discovery, go at throttle up.
There we go. Alright, dudes. I'm gonna mute for a second and let Timmy talk for a moment. I'm just gonna eat my dinner. Just literally a couple bags of cheeses. And I'm gonna try to sip on this hot chocolate because, yeah, got pretty real quick. Be right back a second. No, I didn't bring enough snacks for you. You haven't been sitting here for like 14 hours. You're gonna V6 shop it pain free? No, inline 6, dude. You get a 4-liter and drive it up here, dude. We'll do it. I mean, you get the, yeah, 4-liter, yeah. What's the difference? A V6 pop has 6 pistons, and the 6 pistons are in a V configuration, like this. An inline 6 is 6 pistons that are inline, like that. The inline 6, that inline 6 Jeep motor is a good motor. It's a 4-liter engine, really nice. It'll bolt. Yeah. Why, it'll bolt. Is the launch today? Yep. You have a 350 dually? What? What year? Sold the Hellcat? Oh. Pretty cool truck. Nice. Oh, there's Timmy.
Tim Dodd, the Everyday Astronaut. Welcome to a little bit chilly Vandenberg, California. I am here with a beautiful rocket sitting on a launch pad, and everything is looking fantastic. We are here today, of course, for Firefly's Alpha rocket. Everything's looking good, guys. I mean, except for the fact that I'm chilly. Other than that, everything is go across the board. So things are looking fantastic. And of course, as we do here, actually, even before we do this, I did want to say a real quick to all of our friends and family that are in Florida right now. Our hearts go out to you. You know, obviously, Hurricane Ian has really.
What's the purpose of this launch? This is Firefly Test Flight 2. Firefly's first test flight did not end very well. An engine shut off or voided itself on the way up, and the thing spun out of control and blew up. Firefly is attempting their second orbital launch attempt. Out of all the new space commercial companies, Firefly will be the fifth. They're the fifth one to try going at an orbit. The other companies that, the other like kind of new space commercial space providers that have gotten into orbit are SpaceX, Astra, Virgin Orbit, and Rocket Lab, and that's it. Firefly is gonna try to see if they can throw their hat into the ring here and get that Alpha rocket into space. So, we'll see. I'm going to let Tim talk while I finish my snap.
On the West Coast. So you can see here our T clock in the top left shows us T minus 1 hour and 24 minutes. So that's fantastic. All things are looking good. So that's, so that's at 7. Actually, it looks like maybe I swear I updated my website. It's going to be like, you didn't update. But it is the actual T0 time. The launch window is actually from 12:01 midnight until 2 a.m. midnight. But the T0 time right now on the clock is 12:07, so 7 minutes after midnight. But everything's tracking great for that. The mission name for this is FLTA-002, also known as To the Black. This is the second orbital launch attempt for, which rocket is this? This is Firefly Aerospace. So this is super exciting. I don't know if you guys were out here 2 weeks ago joining our stream when it was a daylight launch attempt. Now it is smack at midnight, basically, and but it's gonna be great. I mean, everything is looking so good that we're all just gonna be super excited to get this thing off the ground, of course. So the customer for this, now this is interesting because this actually has a handful of people on board. This is going to have, and we're going to be talking about some of the payloads on board. We'll show you guys a couple little video teasers of some of the things that are on board, but I'll just kind of list a few of them here. First, this is going to be Firefly, NASA, Teachers in Space, Libre Space Foundation, AMSAT Spain, and FOSA Systems. Now, the rocket for this is Firefly's Alpha rocket. And, of course, again, we'll talk about that in a second. The launch location for this is out at Slick 2 in Vandenberg Space Force Base, which is, of course, you'll notice I said Space Force Base. It used to be Vandenberg Air Force Base. Now it is a Space Force Base. Slick 2 is where the Delta II used to launch from. It's a really cool launch pad, but as you'll be able to see, too, when we get some of our other shots up there, it is stripped down to the bare bones here, and very sleek and simple. And I mean, there's almost no it's just crazy how simple they made everything out there on Slick 2. So the payload mass for this is only about 35 kilograms. That's actually a really, really lightweight payload, especially for a rocket of this size that can carry over a metric ton into orbit tonight. Just as their demonstration mission, this is just a test flight. They're just trying to get something into orbit, just trying to demonstrate how the rocket's capable. Nice and easy, 35 kilograms. This is a breeze for this beast. Where are these satellites going? They're going to eventually end up at a 300-kilometer low Earth orbit at, and hear this, 137-degree inclination. So, yes, this is flying retrograde. This is more or less flying almost backwards to the rotation of the Earth. Even though our latitude here, we're further north than you would be if you're in Florida at Kennedy Space Center. The difference here is we're, of course, on the West Coast, so you can't overfly land. You can't fly east from California without overflying, Santa Barbara or Los Angeles or Las Vegas. Some of these bigger cities, and, of course, with rockets, that's still considered a no-no. So therefore, when you're launching from Vandenberg, you either fly south or some corridor west, so you're flying over the Pacific Ocean, and that is the case today. They're flying a nice, safe, and simple trajectory at 137-degree inclination. So kind of different. I've never, outside of Firefly and these launches, I've never actually covered a launch that goes backwards. That's exactly what this does. Will they be attempting to recover the first stage? That is not a capability of Firefly's Alpha rocket. So therefore, the first stage will splash down into the Pacific. And also same with the fairing recovery. That is not a capability of the Alpha. So these are brand new fairings. Now the weather is currently, get this, 100% go. I don't think I've hardly ever heard that, especially out here at Vandenberg. But last I heard, 100% go. So that is just fantastic. Obviously, that's what we want to hear out here. So this is the second launch of the Alpha rocket. This is the second launch in total for Firefly, the company. This is the first launch of Firefly this year. This is the 10th launch from Vandenberg this year, and the 124th orbital launch attempt of 2022. Busy year, my friends. So yeah, we've got a few things here. You can see on our website we actually have a handful of the payloads in here. So the first one we actually have is Teachers in Space, and this is we actually have a little video here to show about Teachers in Space, and I think we'll go ahead and show you that now. Maybe. I wish like so bad I could be like, here you go. Maybe either that or the NASA one. I'm not sure. Okay, we're pulling up Teachers in Space. Here we go. This is a little video about Teachers in Space.
On this upcoming mission, we have
Reaver
3
engines.
payloads flying with us. All of them are very experimental and heavily into research and development, and specifically about raising awareness in space.
Teachers in Space, we provide actual space opportunities for teachers to actually be embedded in preparing a rocket for launch, preparing a satellite, integrating the satellite. Firefly have given us a brilliant opportunity to launch our own first educational orbital satellite.
The idea behind Serenity was to build a carrier that we could use for student experiments. Now we're doing the ultimate test on orbit. And if it turns out to work, now we have a tool that we can put in our tool belt
Cool.
to help astronauts
nice door
with
crunch.
radiation.
We're putting a blockchain experiment into space. What we're looking for is to test how we can communicate efficiently from the Earth to a blockchain satellite, perform various types of transactions. This is the beginning of several types of experiments we want to do to test the limits of blockchains in space.
I'm looking forward to the Serenity 4, 5, and 6. I want to see what those are going to look like and what experiments the students are going to bring. We want to give them the opportunity to put that on orbit and do something amazing.
We are up and running between the teaching, the launching, and the receiving and analyzing and presenting of the data, and it's like we have our own space program for teachers.
Cool. Dude with the glasses had an MIT shirt on.
All right, so
Nice.
yeah, that's a pretty awesome little thing there. But the next one that we actually have is NASA TESS. This is the Tech Ed Sat 15, and this one I'm actually really excited about this because I think that this is something that we have to be considering a lot as there's more and more satellites getting up into orbit, and as space is getting busier and busier these days. This is a demonstrator that it's actually going to help demonstrate that you can deorbit payloads and deorbit CubeSats. And
Uh-oh.
yeah, this is called the Tech Ed Sat 15. We've got a video of that as well.
He's back. We're good. He's back. All right. So let's.
Commercial space. We collaborate with our young professionals within NASA, private industry, universities, and basically use this as a cauldron to advance a lot of technologies through experiments. In this case, it's helping to supply a very quick turnaround nanosatellite to the Firefly team.
The Tech Education Satellite Series is a rapid prototype series of incremental CubeSat developments. It's a good pathfinder for new launch vehicles, which helps reduce the risk that we have for other NASA missions.
There's so much you can do with small cube satellites. I mean, we can help with climate change. We can help with climates in Mars, climates in Venus.
We're doing pathfinding efforts to enable, manufacturing and
Yeah,
low Earth
stealthy.
orbit.
We're really
These are little
interested
guys.
in taking the
Just
nanosatellite
little
concept
guys.
and moving
Like
that to
shoebox,
the
maybe.
lunar environment as well as Mars.
Our primary payload actually for TechEdsat 15 is our exoatmospheric braking device, which we like to call our ExoBrake. Our ExoBrake is made out of a material that's the same exact thermal blanketed material that was on the space shuttle, which enables us to have a certain amount of control authority in regions of our atmosphere where most other CubeSats cannot.
We're also flying solar panels that are commercial off-the-shelf units that lowers the cost of the most critical components of our satellite.
Sorry, guys.
I could actually command the satellite using email, actually. While we were quarantined at home, I was actually commanding satellites in my bedroom.
I got my aerospace engineering degree from San Jose State. You're taught very practical things from the get-go. That translated almost seamlessly into industry work, especially at NASA, and integrating here with Firefly.
Actually, she was in a very strategic location, being next to NASA Ames Research Center, and being near Silicon Valley, we have an opportunity to work with technology that's actually cutting edge, and then be able to apply that in a space environment.
My generation is involved in watching all the Apollo launches when I was a child, and always wanted to work at NASA and teach and be part of this.
We have the job of turning science fiction into science fact.
It's an opportunity for me to also work with our younger staff and excite them. They're going to define the next generation of space and space exploration.
So yeah, that's the Tech Ed Sat 15, but there's actually a handful of other cool things too. There's the Libre Space Foundation Pico Bus. There's the AMSat EA Genesis G
no, we're not
J,
saving that
and
for
the
later.
FOSA Systems FOSA Sat
Nah, bruh.
1B. Now we have again a full rundown on all of the small payloads on here, and like I said, this Firefly, the rocket's taking it pretty easy with this light of a payload. This vehicle is capable of a lot more, but for your first mission, obviously a demonstration mission like this, you just want to keep it light and easy for it. No big deal. So this is the kind of the things we're hoping to see here. We're coming up on, as you can tell, it's T-minus 1 hour. So we're well into the count, and we're going to hear commentary about terminal count for the go-no-go poll around T-minus 20 seconds. That's kind of the next time we'll be checking in with mission control and all that stuff. But yeah, there's if you guys want to read more about Firefly's Alpha rocket and all of the different things that it does and why it's cool and unique, and even the things that they've upgraded and changed compared to the first one, again, go to everydayastronaut.com, click on pre-launch previews, and everyone in chat, please say thank you to Florian for writing this awesome article, and to the rest of our website crew for just keeping this all up to date, which helps inform me. So yeah, thank you very much, website crew. It's pretty exciting to be here, guys. I got to say,
Cool.
One thing to keep in mind here, this is a demonstration mission. This is still a new space company with a rocket that you can see the condensation on it this time. That's cool. We couldn't see that out when it was warm the other day, but it's a lot chillier today. I'm keeping my hands in my pockets with a hand warmer. Even it's that chilly. And you can see the condensation, the ice buildup on the outside of the rocket. But yeah, the fun thing to remember, we're actually witnessing, it's not very often that a rocket company is going to show us, let us put 4K cameras on one of their very first launch attempts ever. I mean, this is still a developmental rocket. This is still a brand new system. So they're
Really
showing us
cool.
everything, which is just super exciting for me. I had the opportunity to speak with Bill Weber, the CEO, the other day, and he was going, yeah, this is a demonstration. We're hoping that it goes great, and in case it doesn't, he's like, we do have another one right there ready to go. I mean, they're ready to crank on these things, but they have high confidence that this vehicle is going to do great, and they're hoping to at least just get through a few of those key milestones, and that's mission success for them. Really, would be being able to demonstrate out a few more subsystems than they were able to on their first launch attempt. And yeah, frankly, I mean, having been up close and personal with it, everything's looking fantastic. Really impressed with the calm nature of the teams, especially now there has been a little bit of a 2-week stand down. You can tell everyone's just like, sweet, let's do this. And that's just fun for me to see. So yeah. There we go. We got a little shot of mission control there. So we got all the teams there. So far, as far as we know, they're working no issues, which is, again, pretty amazing for a company this young to be able to be doing that. So let's get to a few of your guys' questions and things like that, too. Let's see. I saw a couple really great questions, and I wanted to make sure. First off, like this one. Hopefully we were able to address this during the pre-launch preview, but just in case you're wondering, and just in case you didn't notice in the top left hand of the screen, Slick 2, Vandenberg Space Force Base. So to answer Benevolent Misanthrope, where is this one launching from? It is launching from Vandenberg Space Force Base in California. I like to normally say in sunny California. That is absolutely not the case right now. And it is unfortunately fairly...
What's that for, Lynn? What happened to the first one again? Well, they had first stage engine failure. One of the engines basically flamed out probably about 4 or 5 seconds after ignition, and the other three Reaver engines in the first stage tried to compensate, and it got to the point where they just couldn't compensate for that loss of thrust anymore, and the vehicle spun out, literally drifted. Like it looked like KSP. I don't want to show it because I always think that's bad juju to show failure before we watch a launch, right? But the range did terminate it after it started spinning out of control. Turns out, yeah, see, one of those four. Not those exact ones. The exact ones are at the bottom of the ocean. One of the Reavers. So it turns out that their first test flight had what? Staging view. One of the engine that failed was the engine that Firefly had with the most amount of runtime. They used engines that were near end of life, and because they were near EOL, it failed. It failed because it was old. It was one of their test mule engines that they put on their first orbital booster. I'm not 100% sure why you would do that, but this is right from Firefly. I know people that work there. This is coming right from somebody who is here. Hang on. I know somebody on their senior leadership team. This is coming right from that guy. And he was telling me that, yeah, the engine failed because it was old. It was their test mule engine, and they learned a lot from that flight, and hopefully you learn a bunch, and hopefully we get into space. I would call this one a pretty damn good success if they can get to main engine cutoff and staging. But yeah, I don't think we were supposed to see that plumbing view, Hank. But yeah. Reaver engines only gimbal in one direction, right? Yeah, we got a Soyuz thing going on here. So there's 4 engines, right? 2 of them do this, and 2 of them do that. So, yeah, you need all 4. If you don't have all 4 engines working, over time you're drastically going to lose thrust vector capability on one axis, and that's exactly what happened. It'll just. Has any company got to orbit on the first try? I'm not sure. I want to say Rocket Lab? Rocket Lab got like 97% of the way there on their first try. They didn't get their if I'm remembering right, they didn't get their what's it called? They didn't get the mixture right. Virgin Orbit did not make it on their first try. No. Their first attempt the motor flamed out and the thing just went. Rocket Lab got really close. SpaceX. Nah, they really didn't get close. The 4th flight was the one that went. Yeah, everybody fails on the first jump. Yeah, I don't think. Did you look at the rocket in the red livery? No. Korea with Nuri made it on the first try, but it failed to deploy the payload. Yeah. Yeah. Anyway, let's see what Tim's up
That may be all surprising. You guys have probably seen it, but we'll pull that up at some point too. So, this is a good question from John S. Is it flying north or south from the pad? So it's actually flying more or less southwest. Quite a bit west, though. That's actually, hey, look at that. We already got that pulled up on our feed, too, where you see all the specs of the rocket. I think that's pretty awesome.
That's pretty neat.
That's cool. But yeah, so.
The shuttle made it on the first try with people on board. Yeah, it did. Doesn't Tim work for Rocket Lab? No. Tim is an independent STEM outreach educator, RJ. He does exactly what I do, but on YouTube. I would argue that he's better at it than I am. Like, yeah, I would argue he's better, but he is handling Firefly's cast here. Yeah, he's doing the cast for Firefly, just like NASA Spaceflight was doing casts for Astra. Rocket Lab does use his music, yeah. Tim's a cool dude. I've met him once in real life, but we've talked other times. He's a good dude. Yeah. Really smart. Really smart guy. And, you know, like, we like a lot of same stuff. We like, you know, like music. Tim likes cars and trucks. He just doesn't show it as much as I do. But yeah, and he's crazy about space, dude. He's a good dude. Like, I'd love to hang out more. That'd be really cool. Just, yeah. Yeah, his videos are super informative. Like, super. They're really, really well done. Yeah, no qualms, dude. The information, I mean, he really did. You could tell in his videos, the guy really does his due diligence. He does his due diligence to convey the correct information, you know, the concepts of engineering. Yeah, no, he does great. I got no complaints, dude. Hey, Matt Comart. Thanks for the raid, man. Yeah, the air is one thing, kind of. Yeah, it is what it is. Yeah, I mean, his interviews with Elon are amazing. They're really good. Ton of good information from that. Have you seen the RDE, rotating detonation? Yep. It's not pulse detonation because it's rotating her, but yes. Hey, Alex, what's going on? Matt, thank you very much for the raid, buddy. I do appreciate it. Tim's quality, but EJ, you do quantity and variety. I like you both for different reasons. Yeah, Caden, that's just like, dude, that's Twitch. Oh, there's Luna. Yeah, that's cool.
You just see me with a high key light there, really, really high contrast point light, and I love it. But yeah, this is where we are tonight.
No problem. Wanted to see the launch as well. Sweet.
Hopefully this is going to be the first launch that Luna sees.
Come state? I'm good, Valix. How are you? Bene. Yeah, Caden, I mean, that's kind of like YouTube versus Twitch, man. Dude, I would love to do videos. I'd love to do videos like Tim's videos. They're really cool, but like, where am I going to find the time to do that, dude? If you're streaming, like, I have to do quantity because streaming, you know? But yeah, I'd love to do videos like that. T-minus is in the top left corner. We're about an hour out, T-man.
Actually going to be going out they have little vents just to make.
I mean, better yet, dude, I'd love to do a collab vid with him, but yeah, our schedules are too crazy. Not that he's ever asked, but I've never asked either. 100% go on the weather, Alex. Yeah, everything's looking good. If you hired an editor, you could turn streaming content into vids, but that involves hiring an editor. Crumpet, I've always had what would a collab video ideally be about? I don't know, man. I'd like to think, Novus, that I'd make a pretty good color commentator. Not like the main commentator. For like a launch. So like, you know how like in a typical like sports cast, you have the main guy that's commentating the launch, and then you have like kind of the technical guy that does the color. You know, like, oh, I think an engine failed at this point. You know, we have to look into it. Like what Martin Brundle does for Formula One. I think I'd be good in that capacity, but who knows? Slick 2 at Vandenberg Air Force Base, RJ. Hey, Astro, what's going on? But yeah, Crumpet, I would love to hire an editor. I want to hire an editor, but I can't really afford to hire an editor. That's the thing. Like, if I was hiring an editor, I'd have to pay them peanuts. Like, not what their time is worth. So, I believe in getting paid for your work and getting compensated correctly. I don't believe in if I'm going to take on workers, I'm not going to underpay them unless they're totally okay with it. So, I guess I need to learn how to edit things. You know what I'm saying? How long to the launch? We're about an hour out. But don't worry, guys. You know, like with the compound that we have here now, maybe that changes in the future. You know, what if you give them a percentage of your YouTube ads, like 50%? I don't know. I mean, Forlord, like, that's the other thing. If I hire someone, then I have to incorporate. And then that involves all kinds of crazy expenses to incorporate. I know what somebody's going to say. I'll use Derp website and incorporate it in 5 minutes. No. If I'm going to do it, I'm going to do it right. And incorporating and hiring people and contracting them out and then handing out 1099s, right? That's involvement. I'm going to need somebody to manage that. I can't manage that and stream 60 hours a week. It doesn't work that way. So this has always been my quandary. I would love to do YouTube vids like Timmy does. I would love to. I'd love to go to these launches and cover them. But like Tim, if he goes and covers stuff, right? People are always watching his videos. They always watch videos. He always makes money off that. You know, and once again, I'm not trying to make excuses. I'm not saying there's not a way. We can do it. I just got to figure out the real right way that I'm comfortable with, you know? I'm exhausted. 20-hour workday. Damn, Atran. Thanks for covering this. Hey, no problem, dude. So, yeah, I just got to... I've gotten to the point where I want to, and I think I can manage my time well enough to figure out a way to do this. But, yeah, it's going to... I'm confident that I have a solution, but I have to kind of piece it all together, if that makes sense. But yeah, you know, we're going to have to incorporate if we really want to do an editor or something, and then I have to contract out, and I won't underpay people. But, you know, if you're getting into 50-50 and a rev split, stuff like that, that complicates taxes. And that complicates, now money is involved, you know? And you know how I feel about cash, like money in general. Like, I still get weird feelings when people tip the stream, you know? But I understand that at the same time, I can't just always sit here and just, you know, be like, oh, thanks for tipping the stream. You know, I want to take the stream to the next level. And, you know, like, the crazy thing is, for the longest time, I was afraid. I was afraid to do it. I was afraid to take the step. I'm not afraid anymore. The pandemic and seeing all that crap go down kind of just removed it. That anxiety is not there anymore. So, like, the house is a good example. Like, I was willing to invest in the business, right? It's already paying off. You guys definitely like these streams with the better setup and the better lighting. Like, the numbers don't lie, you know? Haven't even played Kerbal.
Go at throttle up.
Oh, somebody gifted 5. Thanks. But yeah, like, for the longest time, dudes, I was scared to do it. I'm not going to lie to you. So scared to take that step. I'm not really too incredibly scared about it anymore. Yeah, if that's what we have to do, that's what we have to do, you know? Like, I'm trying to find a way to make it work, but let me get the auto streams ready to go. Like, we tested the auto stream this morning. I say this morning, that was like 14-15 hours ago. But thanks for gifting 5 subs, whoever did that. Yeah, kidding. Yeah, I gotta really do out a business plan. And I'll be honest with you guys, if I'm gonna make YouTube videos, I went to school for 3D art and computer animation, but we did have film classes. I know about key lighting, I know about fill lighting, I know about camera angles, ISO, f-stop, stuff like that. I know all the film stuff, like lighting, how lighting is super important, sound, stuff like that. If I'm going to do a production like that, it's going to be a production. I'm not going to make... It's not going to be... I don't want to say low quality content like you'd get here on the stream. But the streaming, I mean, somebody said it in chat. Streaming is very low quality content compared to like a produced YouTube video, you know. Twitch streaming is a one-man show or one man or woman show. And I'm the producer, I'm the director, I'm the editor, I'm everything. and I'm the news anchor, you know what I mean? So, it's just an option, but you could do it and not prioritize what you do. Sound is super important, arguably more. Oh, I agree. I have to go to school, third day of engineering. All right. Arrivederci. Easy to say. Yeah, exactly, kidden. If I'm going to do a production, it's going to be done right. I'm talking script, syndicated content, and that's going to take time. It's going to take time. I'm talking about doing dailies. If anybody works in film, you know exactly what I'm talking about. I'm talking about doing it right. I'm not gonna make YouTube content that just is like everybody else's. You know what I mean? Just like in Kerbal, I'm not gonna play the way everybody else wants me to play. Screw that. I'll play the way that I like, and that usually pays off. You know. You kill it, man. I know you will. Yeah, A-Train. Yeah, dude. I'll admit, dude, you know, for somebody as confident as I am in my abilities, man, I had the craziest anxiety about even going down to Florida and talking to people that work in the industry for the longest time. You know? So wait and just you have till you have time, like if you run out of stuff to do. Yeah, maybe. Actually, a thing that I thought, guys, and you know, while we're here, we're 53 minutes out on the Firefly launch. You thinking going down to Artemis 1 now that it's delayed? Novus, I want to go down to Artemis 1, but I'll be 100% honest with you. I'd love to see SLS in person, but I have no way of really covering it correctly. You know what I mean? I have no way of covering it out there. Do I want to go down to Artemis 1 because I want to see Artemis 1, or do I want to do what's right for the stream? You know what I mean? I love commentating. I love commentating on the launches on the internet. It's easy to do. It's not easy to do, right? Like, you have to be ready and you have to be able to answer questions from like 2,800, 3,000, 4,000 people. That gets tough real quick. But, you know, I can't help but think, like, could I do that with the rocket in the background? You know? I think I could. But how's that different than what Tim does or what NASA Spaceflight does? How's that any different? Like, yeah, it's me and it's on Twitch, I suppose. You know, like I'm not trying to make excuses. Like, I think we could get it done, but then there's the question, like, what if the internet goes out in the middle of the cast? Then it's not even worth it. Then I wasted a ton of time. And I mean, yes, I get to enjoy the launch, but you know, high profile launches are great opportunities to grow the stream, and working on it remote like what I do is that's the great way. That's the best way to grow the stream, you know? That's a learning curve. You can't expect it to be perfect on the first try. Oh, yeah, no. I know. Going up with Tim? Yeah, I think Tim wants to... I don't think he'd want a co-commentators. How about rocket sciencey type videos that you could clip from the stream? Those are always really helpful. I mean, we basically do that right now, Astro, but yeah. As someone who works for a YouTuber, I fully understand you. If you have any questions, you ever want to feel free to DM. I've been doing video stuff for about 4 years, so I'm no vet, but I have some knowledge. I don't know. Yeah, Spoon, maybe. Yeah. Like, another idea, I'm sorry, I was going to say it. Sorry, it's getting a little bit late. Another idea that I thought was kind of an interesting thing that we could do is, so say I take 1 week, and we only do space news for that 1 week. You know, I log in, we do space news, And then during that week, I update you guys with what's going on. And like the streams are only like 4 hours a day for the week, right? And you know, I'll spend the day basically making a video about spaceflight or something. You know what I mean? Or we make a video about working on the truck, right? You know, you make the video, you release it on YouTube. You know, oh, today we're going to change the tires or something, right? And then what we could do is I could, you know, the way I'm thinking about it is like if I was streaming this, right? I would have to stop like 1,000 times through the process of taking 5 lug nuts off and putting a new tire on to explain what I'm doing, to explain how the truck works, to explain what I'm working on, etc., etc. What we could do is I could post the thing on YouTube and then we could watch the video here on Twitch and I could provide commentary, like DVD commentary almost, to what I'm doing. And I could explain it as the video goes on, very similar to how I explain what's going on with SpaceX. Like with the NASA spaceflight footage, you know? I can see you doing Chris Fix type videos, but with your own twist. Yeah. Is that going to be the plan for all future high-profile launches? Stream from home? No, Novus. If I could find a way to do what I do here at, like, the KSC press site, I'm doing it. I'm doing it. Like, I mean, it's like Timmy's van. It's like Luna, the news van that he has. Literally do that. You know, and then like stream inside the van, right? And then open the door and have a camera like pointing out the door, like at the rocket, or have PTZs on top of the vehicle or something and then point those. You know what I mean? Like that would be ideal. When is Firefly? We're about 48 minutes out. Because Noah's, I'd love to go down there. I love going down to launches. It's so fun. It's such a good time, you know, you getting on the press crew, etc., etc. It's fun, man. You know, and then sometimes you get to see stuff like when when I walked on the mobile launcher and stuff. Sometimes they show you stuff that you're that you don't really get to see, like the mobile launcher. Yeah, advanced KSP gameplay, Astro, I think is what's gonna work with YouTube, you know what I mean? The community is top-notch, makes it fun. Yeah, A-Train, I agree. We should get your view what Starling launches. Well, yeah, that's a trip, Foo Face. That's a trip down to the Cape. That's a week away from streaming, dude. I would watch the Space News daily. Yep. Yeah. A good way to start into YouTube is streaming. Yeah, I've got 10 years of streaming experience under my belt. Come set up at the house, man. I have 2 mobile internet options. How far are you away from the Cape, White? I don't even know where you live anymore. We're going to race Monza on the video game. Monza on the video game. And F1 Manager? It's not going to be for a little bit. Yeah, exactly, Spoon. You know, I should have gotten in with DOS when DOS was doing it. Back in like 2017, 2018. I should have just started going down the Cape. Yeah, it would have gotten expensive, but it would have paid off. Yeah. I'll give you a call tomorrow. You have some ideas. Or Saturday. All right, yeah, just call me in the morning, dude. I'm awake I wake up at 8, and then, I got my daily starting routine, and then from 9 to 12, I'm free. When do you think you race Monza? I don't know. I have no idea, JSTM. Yeah, I mean, this is stuff I have to do, like, at this point. If we really want to take the stream to the next level, we want to take the EJ community to the next level, we got to do this stuff. Got it, I might go jump off a bridge after this Monaco race. Okay? It's hard to be unique in something like that, though. Spoon, that's why. I would want the... okay, this is going to sound weird, but I want the intimacy of, like, this right now. But then, when the rocket starts going, like, you open the door out the back of the van or something, and... Or we have cameras on top, and we, you know, I'll commentate it right in, right? And then, you know... like, I'll put the stream up on... you know, like the NASA cast or and track their cameras, right? And then I'll open the door and go outside and, you know, commentate on what I see. And then, you know, it's not just, oh, the rocket's gone. I can get, you know, close everything up, get back in the van, right? After the rocket launches, and we can cover the entire mission. And then even crazier, like after that, we could just go back to playing games. We could do space news after that at the press site. Like, see what I mean? Like, I need that capability, but that's hard to do. Yeah, exactly. Yeah, that bandit, yeah. I don't think I could stay up for the launch. Gotta head out. All right, Novus. Good night, buddy. Could you record KSP missions without commentary? I feel like a video like that with music and just subtitles would work. It's easy, and a lot of people do it like that. Yeah, a lot of people do it like that, RJ. I'm not doing that. I'm not just copying everybody else. You got to find your own style when you're doing content creation, or else no one cares.
Basically like trying to see what happens when you basically just do a kinetic impactor, when you just basically ram into it. Does it absorb all of that energy, or is it so loose because it's, you know, its gravity well so low that, you know, maybe that clump of material is so loose that it kind of goes, too much energy goes through it.
Maybe
how much does it actually impart in its orbit? And so the cool thing, my favorite thing about this whole mission is that it's orbiting the one that they crashed into. Was it Didymos? Oh man, this is what I get for just trying to talk off the top of my head. It was orbiting another asteroid. So basically, it was a dual asteroid system, and there's a little tiny guy and a little bit bigger guy, and they're both quite small. And that was the one they hit was actually the one orbiting another asteroid, and that's what allows. Now I got a big picture. I'll show you. It's orbiting like this, but it's really hard if they just were to impact just any old asteroid out there. Because the way you actually track orbits, you know, you might be off if you're only measuring things in a couple meters per second. It'd be really hard to see that difference if you just smacked into an asteroid. But if you have one asteroid that's orbiting another, and you know its orbital period, you say like, oh, this takes, we'll make up a number, 5 days to orbit the other asteroid, and then you ram into it, and all of a sudden it goes, oh, now it's 5 days and 2 hours. So you can tell how much energy they actually put in to that other asteroid. I just think that's like the coolest thing ever. Super proud of that. So let's see here. We do have a little update. Actually, range clear currently. We do have a little bit of a potential. The range is watching a cruise ship that is looking like it's flirting with our launch window here, our launch corridor.
Please,
but
no.
Until that actually would be a violation, that's the only update we have for now. Hopefully that's not the case. I feel like Vandenberg, you know, because there's still not a ton of launches out here on the West Coast. It seems like marine traffic, air traffic's not as used to it as they are at the Cape. The Cape's pretty well honed in. Like, it's pretty rare to have a violation for the range. But out here, it's just launches aren't quite as frequent. But you still would think, like, check those charts. Check the charts, people. Let's see here. This is awesome from Brian Myers. Let's see these Reaver engines roar. Yes, please. Oh, we are so ready. Let's see here. This is a great question from Sanchi asking, this shouldn't be a bash, and I understand why you can say it, but why are people putting payloads on rockets that have never had a successful flight? Well, that's why, you know, when it's a demonstration mission, when it's a test flight, it's basically like, hey, we'll do this for free. You know, they're obviously giving away a free ride, and that could potentially be something that could cost millions of dollars. So if you have a relatively simple inexpensive payload, they take that risk. They say, hey, if we could potentially get this thing to space for free, like,
I don't know,
we'll take it, even if it's, 50% chance of success or whatever the odds are given, that's worth it. So you don't want to, that's why you also don't put anything super high priority on a brand new rocket. A lot of people were asking, like back in the day with, SpaceX's Falcon Heavy rocket, why did they just put a car on it? Well, you don't want to put a fancy, expensive, telescope or something that costs $1 billion on a test flight mission, because it's a test flight. You have that expectation that we're going to push it and see how we do, see what works, and hopefully learn a ton. And that's exactly what they're doing here today. So you want to do payloads that are, not costing hundreds of millions of dollars. So that's why they're small CubeSats, and they're taking a little bit higher risk by hoping to get a free ride to orbit. So we'll see. Let's see here. Hopefully I answered this one earlier, Scotty Allen. So does the control scheme, so their particular control scheme, like I said, has opposing pairs. So one pair of engines can kind of control yaw, the other pair of engines can control pitch, and then if they move in opposite, they can all four control roll together if they want to. But each engine is actually only capable of a single axis gimbal. It's not dual axis gimbaling, so they can go just on a single axis. I hope that makes sense. I don't know if I'm doing a very good job of describing that. Let's see. This is a good question here. When does the launch window close? It closes at 2 a.m. Pacific Standard Time. So you'll see that's it's almost coming up on 11:30. We're coming up on, we're almost to, Pacific Daylight Time. Wait, is that what it is?
Yeah.
PDT, Daylight Savings Time. Oh, I hate that. I can't wait for that to be done. For those of you guys that don't know, we're about to get rid of Daylight Savings Time altogether, or at least the switchover. And that's going to be awesome. So, yeah, we're in Pacific Daylight Time, 2 a.m. It's 7 hours behind UTC, so you can do the math there. The window, I think, ends then at 9 UTC. So hopefully that makes sense. All right. Oh, man, Dougal, if I were able to commentate a Saturn V launch, what would I highlight? Holy cow, how would I even know there? Honestly,
you got to go to Atlantis.
Everything, the size, I love things. Okay, some of the structures and the things that I love about the Saturn V. I love, like, the inner tanks. You can see there's these corrugated sections on the Saturn V, these kind of rigid. You'll notice most of the tankage is nice and smooth, but then every now and then you see these weird ridges. Maybe you've never noticed that, but you'll see lines. The Saturn V, that's how they made it structurally rigid between the tanks, because some of the tanks, like on the first stage, didn't have a common bulkhead. They had separate, like a fuel tank and then an oxidizer tank. And there were domes on the top and bottom of each one. So there's a little space there between those two tanks on the same stage of rocket. And so in order to make it structurally beefy, they had to use like kind of corrugate, like zigzag
during Route 154, Toto, I drove through 4 time zones in a week. Yeah, man. Big country, right?
So, yeah, pretty.
It's freaking huge.
Pretty cool. So Matthew Garb wants to know, how long is the delay from real time to YouTube? Good question. With 4K, it is a little over 20 seconds. So if I were you, I would go outside at T-1 minute. That would give you ample time if you're within viewing range in the south. Where are we? Mid coast, California? I'm not sure. Central Coast. There we go. Central Coast, California. If you're Central Coast, yeah, you. I would say at least T-1 minute. So let's see here. Okay.
You might be able to do Cyberlink.
Oh, this is a great question from my left foot. You know what? I have not done this. I don't know if this is coming in on comms tonight or not, but I better do a little confirmation check here from our team.
And I'm sick and I've been streaming for 15
Did I confirm the pointy end is up? You know what? I haven't yet. But this is a fantastic shot to be doing that. And I can confirm here, the pointy end is up. And let's pull up those engines. We'll be able to confirm there that the engine's pointy, flamey end is down, my friends. So this engine is in the correct orientation. And as a rocket orientation specialist, I'm not the best in the business, but at least kind of know. So maybe we'll get mission control to see if they can confirm that for us. So let's see. What page on the website? That's a good question. Let me see if I can find that here. This is from on Firefly's website. You can find firefly.com. Click on launch, and here I'll just show you guys here on their website. Oh, here, let me also pull up the the question here from Ben wanting to know what page on the website. Firefly.com/alpha.
So, fellas, actually a cool thing here. This rocket is launching off of Slick 2 at Vandenberg. The Slick 2 is the pad that's been around at Vandenberg for a good while. It was used to launch Delta 2s. So, here, let me show you. So, if we go to Slick 2 Vandenberg, right? So there it is with the Delta 2 when it was a Delta 2 launch complex. Firefly's rocket is mounted pretty much right there. It's cool because it's got a when it was Delta 2, you had a pedestal, and then you had the hole down to the flame trench, and then that's it. And then Firefly is basically, if you look at the rocket, you can see the same service structures basically in the same exact spot. Now, the cool thing about Slick 2 also Boeing furred, nitrogen furred, just furds everywhere. So Slick 2 is used to launch Delta 2 for the longest time, and I'm not exactly sure what it was used for before that. Oh, it was used to launch Thor missiles. Okay, so a precursor of Delta, and it picked up with Delta 2, and now it's at Firefly Alpha. But when it was a Delta 2 launch pad, it had a very, very unique service structure, okay? That service structure, you know, you'd think that the service structure just stacks the rocket, right? It just stacks the rocket right on the pedestal. The service structure moves forward, stacks the rocket. If we go look at Slick 2, I'll show you. I did it! I freaking woke up! That's good. So, Slick 2 is over here at Vandenberg. Vandenberg's up here. Slick 2 is right there. No, that's an old launch site. Vandenberg has tons of abandoned launch pads from doing missile things. Maybe it's just a bit over here. Yeah, here we go. Yeah, so there it is. That's 2. I just want to be absolutely sure. Yeah, okay. Sweet. So, you see it has that service structure right there. See that? But you know, you think that it just builds it right on the pedestal, but that's not actually the case. Right? That's not actually the case. It was a very interesting way of putting the rocket together. Let me show you. So let's take like IceSat 2 integration. IceSat 2 was the last Delta 2 that was launched from that pad in 2018. And hang on. Let me see if I can we can see this right. Nah. Isn't that parking lot close? Yeah. Nobody's parked there when the rocket goes to launch, but anyway, I digress. So the real thing to look at that's very strange is, you know, okay, so how does this structure right here? It has a bridge crane, right? You see the bridge crane. So bridge cranes basically pick up the vehicle, right? They pick up parts of the rocket and hang them vertically, and then it's basically a crane that looks like a bridge, right? So it picks it up and then it stacks. So you stack the first stage, then you start stacking SRBs, then you stack the second stage, stack the payload fairing, etc., etc. But how does it do it when it's on the pad? Delta has a fixed service structure right here. See the fixed service structure? if that thing moves, because that thing is diagonal and it's opposite of that fixed service structure, see it? That's where it was, right there. You can still see the mounts. How does that bridge crane actually work? Well, the Slick 2 mobile service tower actually picked up the Delta 2 first stage when it was over here. And the thing moved to the launch pad with a Delta 2 core hanging inside of it. Just kind of swinging back and forth. And then they move it forward, move it forward, and then they stack it. And then they back off, and then they take the stage and do the same thing, etc., etc. It's crazy. Yeah, it's one of the only mobile service towers that I've ever seen that moves the core while it's hanging. It's actually really, really interesting. I'm trying to find footage of it somewhere. Maybe the iSat 2 launch highlights. Yeah, so it's a very weird service structure. And in order to move the rocket, right? In order to move the rocket with, like, while it's hanging, there's a huge counterweight on the back. See what I'm talking about? That whole freaking thing, it looks like a giraffe. That whole thing moves back and forth. It moves back and forth here on the, or did move back and forth on those rails. It's since been torn down. Here's a picture of it moving the second stage. Yeah, there you go. That'll do it right there. Check it out. Yeah, see? It'll pick it up, and then it'll move it, and then once the rocket is stacked, it'll basically encompass the whole thing. This will move, and the rocket will be inside of this mobile service tower, and then you have service gantries for doing checkouts on the vehicle. Right? There it is moving a Delta K. But yeah, that thing actually, you'd think that it moves into position, right? And then you start building the rocket. No. That's not how that works. This thing will pick up the thing, and then the whole service structure with the thing hanging will move. It's pretty nuts, dude. It's pretty cool. Like, it was a very unique structure. And then once again, it's counterweighted in the back, right? So here, ULA might show it in this old footage. No. Let's see if they move it. Well, there's the service structure moving back. Now, if you guys are probably looking at that thing and going, it's a very weird looking building, don't you think? It doesn't look, this thing looks like it was, gradually modified and upgraded over time, right? Like, it looks like it was modified and upgraded. It looks like they, like they just kept adding stuff to it. It doesn't look coherent, right? Like Atlas 5's vehicle integration building, right? Or like Slick 6's mobile service structures that move out of the way that are really nice and they're smooth on the outside. This thing just looks like it's a bunch of stuff kind of glued together. NASA stealing your pad design? I based the Dart mobile service tower off of Slick 2, believe it or not. Yeah, that was the inspiration for the design. Like the hanging service structures and going over the launch pedestal and stuff. Yeah, it was inspired from that. So, yeah, see, if you go back a little bit, you see that this whole thing is actually hanging. This whole structure right here is hanging. There's nothing there, so it can cover the pad, right? And the wheels and stuff, the railroad ties for the vehicle, like the railroad bogies, are back here. There's nothing up here. It's just kind of hanging there. In the next shot, they pan up at the service structure, see? These things are kind of floating, and all the wheels are that way. Pretty crazy, right? So, I know what you're thinking. Okay, what are you getting at? What do you mean it looks so weird? Well, that service structure actually, and Slick 2 actually have a lot of heritage. A lot of heritage. That service structure, hear me out. The reason why that service structure looks so weird, like how it's such a strange, weird design, and it looks like a blue giraffe or something. Well, it's part of the Apollo program. True story. Not a lot of people know that. Flick 2 had a mobile service structure on it that was surplus Apollo hardware. Not a lot of people know that. 6 minutes away from go, no go. Yep, sweet. Slick 2. Yeah, that's Apollo hardware. Now, I know what people are going to say. What do you mean? Okay, what Apollo hardware is that? What? The Saturn V didn't use that. Saturn 1B didn't use this. How did it end up at Vandenberg? What do you mean part of the Apollo program? Well, check this out. Saturn, there, you know, the Apollo family of rockets has, you know, Saturn 1, Saturn 1B, right? And then the Saturn V, and then Nova eventually. But there's one more rocket that was part of the family of Apollo rockets. And it's not a rocket that a lot of people know about. It's this thing, what they used to do the abort ascent test. This guy right here. That right there is Little Joe 2 rocket, which is basically a bunch of rocket stages kind of clustered together. They used it to test the launch escape system for the Apollo program. Now, I don't know if we could necessarily get a picture of it, but if we start looking at Little Joe 2 here, where was this tested? Well, it was tested out at, I think it was White Sands. They used Complex 36 at White Sands Missile Range. Little Joe 2 was launched on basically just a launch mount that was tilted, and that's it. But it had a service structure. It had a mobile service tower for putting the rocket together. Guess what service tower it was? Yeah, same thing. Same thing. Yep. Hey, you streamed late today. Yep. I'm trying to see if we can find a picture. Oh, there it is. There it is. Same structure. Delta 2's pad is ex-Apollo hardware. Pretty crazy, huh? There it is. After this, it was declared surplus, right? After the Little Joe 2 tests were done, it was declared surplus, and they moved it to Vandenberg and then cut the thing in half right here and extended it and used it, and they used it to integrate Delta boosters for like, I don't know, 40 years or something. Have you ever been to White Sands? Yep. That was Spaceport America. So if you look at the bridge crane up at the top, dead giveaway. Literally the same thing. That's a picture of the same thing, but these two pictures are about 50 years apart. So, yeah, Slick 2 has a lot of history, and that history can trace its roots right to the Apollo program. Pretty cool, huh? Yeah, if you want to know why this service structure ended up looking so goofy, it's literally, it's an oil derrick. Bridge cranes are used in oil drilling operations all the time. That's where they got the idea for using a bridge crane to integrate a rocket. This is oil. NASA bought this from an oil company because it was used for staging an oil derrick. Yep, true story. And then they retrofitted it to be a rocket service structure. And then they modified it again to be a Delta rocket service structure. Yeah, it's ex-oil infrastructure. And then ex-Apollo infrastructure on top of that. Now, where is it nowadays? I don't know. Thumbtacks? They scrapped it. They scrapped it when they ended the Delta 2 program. So, yeah, little cool thing on Slick 2. Slick 2 actually has a lot of cool history that not a lot of people know about.
That's going to be awesome. So hopefully that is exactly the case. Let's see here. Oh, this is awesome. From Republic Capital, proud investors of Firefly. I thank you for saying I'm doing an amazing job. 2 a.m. Out here in New York City. Oh man, they got it's going to be 3 a.m. by the time this thing launches. So thank you for staying up with us from Republic Capital, and thanks for investing in New Space and a company that's going big for their first. This is, again, I don't think people understand how big this is compared to most small launch vehicles. This is a really big and ambitious small launch vehicle. I mean, being able to lift over 1,000 kilograms for a small lift launcher is a lot. So yeah, I think we're coming up here. Hopefully the teams are getting ready to do the go no go poll, and we'll be able to bring that on air and show you guys mission control as they go through that. And that's going to be, I can't wait. The go no go poll always makes me just get a little bit. It's just such a hype building experience. Just yeah, super excited. So all right, we're waiting on them to start with that, and as soon as we get that, we'll let you know. Here, I'll answer one more question here from Spencer. Will this launch be visible from LA? It might be. It will be, depending on weather for you, if it's clear skies or not, you might be able to catch it a little bit, but it is flying a little bit more west. So, all right, here we go. Stand by for the go no go poll from Mission Control.
Go. GSW.
Go.
GNC.
Go.
Prop 1.
Go.
Fluids 1.
Go.
Structures.
Jet.
Go.
AVI.
Go.
FTS.
Go.
GC.
Go.
VC.
Go.
PMM.
Go.
OSM.
Go.
LWO.
That guy
Launch
just
weather
did
officer.
this.
We'll come back. CE.
Go.
LD.
Go.
LWO.
Weather officer, please.
I'm aware. VC, please put the vehicle state machine into flight mode.
Copy that. Vehicles position to flight.
You didn't get a go for weather.
Transition vehicle to flight.
Unless they did it on a back end loop.
Prepare hydraulics for terminal count.
Copy.
Verify set the operation selector to launch.
Copy, can confirm vehicle status, vehicle launch. Select.
Please run hydraulic strong back auto pinner engage auto sequence.
Okay.
Copy, running. Hide SB auto pinner engage.
Please announce when we get positive pressure.
Well, I think we're still waiting to hear for a final go from mission director, from launch director Megan Roth. Did I miss it? Or were they still waiting on one more?
Copy that.
Well, she set the rocket.
They did put the
flight.
rocket into.
They put the rocket into flight. They put the rocket into flight mode, and Megan commanded for basically the standby for auto sequencer start, which means, yeah, the rocket's pretty much ready to. They're ready to hit the go button
Across the board, but
engage.
Yes.
Running.
Okay, hopefully, and we'll be able to listen to comms 2 here after this until about T-minus 10 minutes. We'll be able to bring it back
Confirm,
in.
please confirm.
But I think we're actually going to go. So, yeah. All right, so we'll keep going here, answering a few more of you guys' questions. This is a good question from Jeff Dew 83. How far are we from the rocket? So actually, our vantage point here, we're about 7 miles. So what is that, like 11.5 kilometers, 11 kilometers or so. We're a decent ways out. But we had to be tied into the fiber lines here at this NASA building. So it's really cool where we're at. Again, the history of Vandenberg is just amazing. And the infrastructure out here is pretty awesome. So to be able to have fiber. Okay, we have official go. They are go for launch. That is awesome. All right, that is, yes. All right, let's do this. Ryan, you ready? You freezing? Yes, this is awesome. Okay, we are go for launch. We are coming up here. You can see Ryan on camera there a little bit here. Ryan, wave to that camera out there. Ryan Chalinsky from Cosmic Perspective out here. We got Allie and Colin in the van running the show. Everyone say thank you to them as well. We're here. We're ready, my friends. This is awesome. The rocket's looking good. We are go, go, go. This is what we want to hear. We want to hear go. This is great news. Let's see. This is a good question actually from Prashant asking, why can't this rocket launch from Florida? And it can. It can and it eventually will. They do have a lease on a pad out there at Cape Canaveral Space Force Station.
19.
And hopefully, once they prove out the rocket's good to go, they'll have operational launch pads on each coast. Because obviously, here at Vandenberg, we have there's kind of a limitation to what flight corridors a rocket can fly. So currently, this can really only fly into polar orbits, or in this case, a retrograde orbit. If you want to fly into a more equatorial orbit or more of a low inclination orbit, you do want to launch from the East Coast. So eventually, once this rocket's certified, ready to fly, they will continue to expand their operations, and they'll have a launch pad in Florida as well. So, heck yeah! Thank you so much for the tip. I really appreciate it. Ted's Fix-It Tech. I really appreciate that. Let's see. This is a good question from Matthew Garb again. How far away? But wanting to know, is it loud? I don't expect it to be too loud. I'm hoping we can hear it this close, but it is, it is a smaller rocket in terms of compared to what just launched the other day, the Delta IV Heavy. It's quite a bit smaller than that, and it's 7 miles away or 11 kilometers ish. I expect to hear it, but I'm not sure if it'll be super, super, super loud. Yeah.
Help you wake up.
That's a great question here from Reese. How is the Reaver and Lightning engine cooled? Is it regenerative or passive? So for those of you that don't know, I did a video deep diving on how you cool a rocket engine, how you keep a rocket engine from melting. And yeah, the Reaver engine and the Lightning engine are both regeneratively cooled engines. So that's pretty awesome. Those are engines that run propellant through them. And then they also, of course, most engines actually also use a little bit of film cooling. So the actual injector face will potentially flow more fuel rich on the outside. So it kind of makes a little bit of a barrier there between the main combustion process. Yeah, so that's, you can kind of employ a lot of tactics, but the engines are regeneratively cooled. So they do run fuel through the engine and through the walls of the engine, and that's what keeps it cool. So, oh, this is awesome! Thank you so much from Ted's Fix-It Tech again from Omaha. Hey,
Omaha.
Let's see here. This is from Samuel. Assuming this launch goes well, what's next for Firefly? Do they have a payload set for the next launch? Oh yeah, they've got rockets lined up and customers waiting to fly. So they're ready here for this demonstration mission to prove out that this rocket is ready for some customers. And this is a big milestone. Again, there's a lot of things that they hope to learn on today's mission. This is a test flight. This is, think of this in the same vein like when we saw SpaceX working with, with Starship. When we see the SN things, they're testing. They're pushing the envelope and seeing what works and what doesn't. You can think of this in the same way. I think this is obviously a lot more higher fidelity test flight mission compared to some of those Starship vehicles that we've seen. But they're expecting to reach orbit, or they're hoping to reach orbit. That's the end goal. But frankly, when it's a demonstration mission like this, just the more things you can check off that are unknowns, that's a win. That's a learning opportunity. So say they get to MECO, if they get all the way through the first stage burn, that's going to be awesome. If they get through stage separation, that's a huge event that's difficult to pass. And again, it's impossible to certify that on the ground and to validate your design on the ground. If you can do second stage ignition in space, that's huge. That's frankly awesome. If you can demonstrate, you can ignite your second, and run your second stage engine in space, that's huge. And then obviously get through the fairing separation would be a really awesome milestone. So the further and further you get into that checklist, the better. So we're really excited for that.
I'm looking at this. Yeah, it's using a film cooling on the injector plate from what I can tell. So Tim wasn't wrong there. That was right. But it's open cycle. So it's an open cycle engine. See how you have the dumps right there? So it's just a gas generator open cycle. But I mean, yeah, you can I mean, I don't know if that's a regenerative cool. Do you call that regenerative cooling? I'm actually not even sure. I think that's just film cooling.
12 launches in a month these days out here in the U.S.
It's a tap? Yeah.
Let's see here.
Yeah, okay.
Nando,
Dude, look at that
launching
thing.
at
That's
night
it's a
cause
tiny
significant
little
changes to launch
guy.
protocols? Now that I'm not actually sure. I would love to have a specific
Yeah, look at
answer.
that thing. Yeah, there's your
I don't
gas
think it really
generator
changes
right
too
there.
much about
Gas generator. There's your turbine
rocket
wheel.
and the trajectory. The main thing is, the range is generally a lot more clear at night. We don't have to.
Or is it a straight tap from the combustion chamber spinning the turbine, and it's a radial turbine?
Airliners, marine traffic can be a lot lower.
Yeah,
too.
radial turbine.
So yeah, it's in general. I
But
don't
no,
think
it's
there's
got.
too much different other than the fact.
Now I'm curious. I don't know too much about these motors.
Oh, this is cool from the launch pad. How you doing, guys? Hey, Tim. Going to be a great night. What's it like being there on site? The sounds, the smells, the atmosphere.
Alpha's first stage is powered by 4. Yeah, okay. It's a LOX RP1 tap off cycle.
Actual temperature. It's 58 degrees Fahrenheit. So what is that like? 20,
Interesting.
20-ish centigrade. It is relatively chilly.
No,
So,
58 degrees
it's chilly,
is
but
like
out of the launch pad,
15°C.
the sounds, you
It's
hear a lot of
pretty cold.
compressing
For
birds,
it's cold for
air
California.
circulators. They have a big nitrogen compressor out there. You hear just different things, kind of like there's just a lot of buzzing and whir. Actually, if you listen to the interview that I did with some of the team members,
It's definer and cold.
when I was out here last time, you will notice when we're sitting. I was sitting with Megan Roth, launch director. I was sitting with her at the engine section of the rocket. You'll notice that the sound sounds a little off because we had to swoop out a ton of noise because there's all these compressors whirring and all these kind of buzzes going, and just literally like it's almost like it's a living, breathing machine, and it takes a whole set of machinery out there to make this thing operate. So yeah, it's super, super cool. So yeah, so this is from High Desert Garden. Is this Firefly's first attempt? If not, how many? This is their second orbital launch attempt. They launched last September, and or was it August? I think it was September, last September. And this is their second launch attempt. Everything's looking.
Human, what's your definition of regeneratively cooled? Because regeneratively cooled is like if you take like the propellants and you put them through the nozzle first and then put them into the rocket engine. If the outside of if the rim of the injector plate is delivering more fuel quantity, that's not regenerative cooling. That's film.
All right.
I'd have to go. Now I want to go look at the RPE, my RPE book from the other room.
This is a good question from maybe Georgie. Why did they let you set up cameras this close? What was the conversation like? Well, don't forget the reason that we have cameras this close.
Yeah, Phil. That's what I was wondering.
We actually let's see. Why did we let the cameras set up? Oh, yeah, what was the conversation? We are the live stream provider here. We are the actual live stream provider. So without our cameras, Colin, you're still on my comms, by the way. Sorry. So yeah, we are the only live stream that you guys have, and Firefly hired us to be the live stream provider. So let's see here. Let's see. What is the total volume of fuel that Alpha needs for flight? And is it the same or similar mix as other rockets we've seen before? So what is the total volume of fuel that Alpha needs for flight? So
it's open cycle.
You can just look at the volume of the vehicle. I don't know if we can pull up the overlay on the size of the rocket, but
it's
98
Carolox
meters tall.
Wombat, so that's just oxygen.
I believe 2 meters wide or 1.8 meters wide, 6 feet wide.
T-minus 7 minutes.
Ooh.
7 minutes.
There we go. We do have comms there, so that's awesome. So I don't know offhand the exact volume, but you can see there the division between the liquid oxygen tanks and the RP1 tank on that first stage.
Wiggles complete, no warnings.
Yeah, that's what I like to hear. No warnings. Oh, that's awesome. So yeah, if you are someone that enjoys doing math, you could figure out the exact volume. Maybe we actually have that here on the. Maybe it shows.
T-minus 6:30.
T-minus 6:30. We're getting close.
FSW, please start a Wireshark capture on the umbilical port PCAP server.
Good work.
Thank you.
This is from Scott Manley, reminding us that there's actually still hundreds
internal power
of images from Lucia Cube, from the mission that we're talking about earlier, from the DART, Double Asteroid Redirect mission.
Lucia Cube is the CubeSat that DART deployed, so it could film DART.
Friendly reminder here, if you haven't kicked your YouTube up into 4K, it's worth it.
T-minus 6 minutes.
T-minus 6 minutes. How you feeling, Ryan? Awesome. Oh man, this is huge from Vegas Brent. Thank you so much, Vegas Brent.
All arms are open.
Sincerely appreciate everything you're doing to continue to promoting space exploration. That is huge. Thank you so much. That makes that helps make all this so worth it. And everyone in chat, please say thank you.
30 seconds. Strong back retract is beginning.
To Vegas Brent, we are seeing the strong back retract beginning. You'll actually, it's hard to notice now with the venting there, but if we go to maybe that other angle that's a little wider, yep, you'll see the thing that was holding the rocket up.
So Firefly, like a lot of other rockets, relies on residual pressure inside of the tanks to be structurally rigid. The only time that thing can really retract is when the rocket's pressed for flight. So, I mean, on top of other things, that's a pretty good indicator that they are set to jet.
We will now perform the verification of SVHR. Per instructions earlier, since we are not waiting, we will just run A2 SVHR cycle check.
Copy. Running. A2 SVHR cycle. Running.
Yeah, baby.
Yeah, Spoon, that'd be cool.
So again, thank you so much, High Desert Garden. Really, really, really appreciate that. Seriously.
Okay.
GSE fluid go on.
Oh, we aborted.
Yeah,
Lost GC GC SDA lost counts.
Something overpressurized there, guys.
Stepping into abort actions at this time.
Yeah, that thing that popped off of the strong back and then the stage, that's not, yeah, that wasn't supposed to happen.
Like it popped back after 2 seconds.
Copy, confirm there are no fires on video. No fires. GC, please close NV 598, 599 Alpha Bravo.
Closed.
GC, confirm the following three valves are closed.
Confirmed.
Helium bubbles active.
Confirmed.
S1 fuel tank is maintained between 30 and 36.
Confirmed.
All other tanks.
Strong back's coming back up. Yeah, that wasn't that pop was not supposed. It was not supposed to do that.
Venting.
Spin system is vented.
All right. Well, as you heard, the teams they have aborted for now. Looks like they may have had some little. We'll wait to hear exactly what that was, but it's no big deal. They do have almost a 2-hour launch window. So, yeah, they're gonna. Hopefully, you can see the strong back retracting here. And they're going to hold on to the rocket until they're able to reset. I think when I talked to engineers last time, they said it takes about, depending on the situation, it can be 45 minutes or so to reset. So we'll wait to hear from the teams on what the cause of the, if there was a cause that is anything that really matters. But realistically, hopefully they'll just give us a new T0 time. So we will stop that clock or put it in hold here as soon as we can, and then we'll await a new T0 time from the teams. And yeah, we'll see here what we can do. So, yep, we are in a hold as you.
GSE fluid go on.
I'm replaying.
Oh, we aborted.
Yep.
Yeah, baby. So again, thank you so much, High Desert Garden. Really, really, really appreciate that. Seriously.
That was continuing.
Cycle. Running.
Yeah, baby. So again, thank you so much, High Desert Garden. Really, really, really appreciate that. Seriously.
That was
Sounds like the guy says valve seal. I don't ever remember a vent being there, Phil. But whatever it was, it stopped.
So again, thank you so much, High Desert Garden.
That could be
really, really, really appreciate that. Seriously.
That was continuing. GSE fluid go on.
Oh, we aborted. Lost GC SDA lost counts.
Copy that. Stepping into abort actions at this time. We lost counts on the GSE SDA.
Confirmed. It looks like it popped back after 2 seconds.
Copy, confirm there are no fires on video. No fires. GC, please close NV 598, 599 Alpha Bravo.
Closed.
GC, confirm the following three valves are closed.
Confirmed.
Fueling bubbles active.
Confirmed.
S1 fuel tank is maintaining between 30 and 36.
Confirmed.
All other tanks are vented.
Confirmed.
GC, please confirm the following. T-type tank is vented.
Vented.
TBC is vented.
Well,
Come out here next time.
Fellas, rockets have all kinds of check valves on them. Think like a steam engine. There's a check valve on purpose. So if the check valve, basically, if it registers a high pressure, it'll pop. I think we saw a check valve working there. I think. Yeah, check valves happen from overpressurization. So for whatever reason, the tank. So we saw two things vent. We saw a vent from out here, and we saw a vent right there. Now, we did see some ice fall off the vehicle. So that tells me that, I mean, the vent right here, if there was a check valve vent, it would be, that's the top of the RP1 tank.
So cool how they're starting to realize, hey, we don't need to be the owners and operators of vehicles anymore. We can just say, hey, here's what we want to do. We want to land on the moon. We want to do X, Y, and Z. And then they just see what partners come up with proposals and award contracts to those with awesome proposals. So it is a really exciting time just because it feels like there's a lot. And they kept saying, NASA really kept reiterating how.
So, like, I'm not sure what happened here. We saw a vent come up from the transporter erector, right? We saw a TE vent, and then we saw an RP1 check valve, which is strange. Yeah, that's peculiar. Wait a minute. That's a lot of venting. Hold on. That looks like a deep press.
This stuff more on the news side of things. I mean, there's just so many talented reporters out there and channels that cover this stuff purely on the news side. It's exhausting. It's hard to keep up with it all these days. I mean, again, 7 years ago.
Guys, that's a chill down, or not a chill down. That's a vent down. See, they depress the tank.
Thank you again to Brett C for becoming a member, and to Josh Mumpower for becoming a member. And thank you very much from Donald. I appreciate you saying I'm doing a good job trying to just not be too cold and keep the excitement going because, hopefully we like I said, we still have an hour and 52 minutes left in this launch.
What can cause that? What can cause that problem? You can get anti-geysering in the LOX system if you didn't get the flow rate right. So if they were like topping the tanks, and they didn't get the flow rate right, and too much LOX evaporated. So like too much LOX evaporated in the line, you could compress the line and overpressurize it. It's called geysering. A lot of when you're dealing with cryogenic propellants, you really have to worry about that because every time you flow a cryogenic propellant through a hot fuel line, so a fuel line that even it's cold in Vandenberg right now, even if you do that, the propellant is still really freaking cold. It's 57 degrees Fahrenheit in Vandenberg, and liquid oxygen is liquid oxygen at minus 293. So we're talking about over 300 degree temperature differential here. When you have a 300 degree temperature delta, you take something really cold and you put it into something really hot, the propellants will conduct the heat. And if your liquid oxygen conducts the heat and it gets too warm, it's going to evaporate and turn into gas. The other thing you got to take into account is that they usually deliver at relatively high pressure. High pressure, extremely low temperature. So you get the LOX basically boils. That's the right thing. Like if you put water on the stove, it boils. So it's always going to be evaporating in some way, shape, or form. So if they didn't get their LOX tank replenishment rates correct, right, you're going to have too much gaseous oxygen build up in the line. And if you have gaseous oxygen build up in the line, and you could basically see pressures that you wouldn't get from just flowing a liquid through there, right? You're going to get overpressurization. In the LOX can end up geysering out the pipe after it pops. So you have differential flow rates for fueling a vehicle with cryogenic propellants. You know, a lot of people learned about these differential flow rates. With SLS, they have, you know, they have the anti-geysering, right? So slow fill, and then fast fill, and then replenish. Those are 3 different flow rates there for a cryogenic propellant. Now, with LOX, you just have slow and fast fill. You don't need, I mean, well, actually, yeah. There's replenish too. So actually, LOX is pretty much the same, but you don't need to, you don't need to worry about it as much as hydrogen. Hydrogen sucks, but LOX is not that bad. It's actually a little more stable when it's doing this, I guess, is the right way to say that. So here, hold on.
Colin, you must be north of Kennedy Space Center because ISS missions will always fly to that 51.6 degree inclination. So that's going pretty much northeast. It's going to go more or less almost following the coast of Florida.
So once again, it looks like they scrubbed their first attempt. It looks like they have a, it looks like they had some kind of geysering event, and check valves, emergency check valves went off, and the mission controllers were reading a overpressurization for 2 seconds, and then vent down, and then spring back into a nominal pressure inside of the tanks. But once again, guys, I'm speculating. I think that's what happened. That's what it looks like, but I could be wrong.
It is unbelievable how much that makes a difference because the sound waves will actually end up like bouncing off the clouds, and that'll be the loudest rockets you ever hear. Is like when there's a cloud layer between.
So the oxygen tank is, these tanks are LOX first, so it's LOX RP1, LOX RP1. The inner stage is right there.
That's where the cloud.
See where that line is? Line down to here. That's the inner stage. So that's where the second stage engine is.
It'll be really loud.
That's where the second stage engine is hanging. It's hanging inside there. The inner stage is a structural cylinder that connects the top of the first stage to the bottom of the second stage. It's in between 2 stages, hence interstage. It's hollow on the inside. The second stage engine is riding inside of it.
Through the engines and do all of these things, priming the rocket to get ready to lift off. Even, you know, getting the vehicle up to flight pressures, all of the different things, and you basically want to kind of talk the rocket back down out of that state and then reset and get back to a place where you're able to go and go through that whole thing. And otherwise, the other option, which would be really hard, is like say you otherwise say you might have like a scrub at T-minus 4 minutes and 41 seconds. You would have to write a procedure for what happens under that exact condition to reset it like to a quicker timeline. So it's just safer and better to get the vehicle back into a safe state and then restart your countdown. So that's basically what the teams are doing right now is they're evaluating what's going on, make sure they are addressing and can understand whatever caused the first scrub. Give yourself a little bit of time to kind of evaluate and, look at the data and say, what's the rocket telling us and what can we do to fix it? And assuming it's something that's like, oh, cool, okay, well, I guess we'll just reset this or make sure this is set to XYZ. I have no idea. I've never been on mission control at all. But that's what these.
Timmy's right about resetting the state. You want to start from last known successful configuration, and in this case, when you enter terminal count with a rocket, last known configuration was right before you entered terminal count. It's like the rocket equivalent of hitting revert to launch. Yeah. So once rockets really get into the auto sequencer, right? So usually you get like, I don't know, it depends on the rocket, like inside of 15 minutes. 15 minutes is like point of no return. Like if you pause the count there, you go back to 15 minutes and then you cycle all the systems to get the rocket into the same configuration that it was when you started the launch sequence, right? That's just being smart. That's just being smart with your implementation. You don't want to, echo in Tim's words, which were basically spot on. You don't want to you don't want to try to start up the count at, like if it scrubs at 4 minutes, like what he said, right? You don't want to try to pick it up right at 4 minutes again, because whatever you were doing in that last configuration caused the vehicle to scrub. So you got to figure out why. You got to figure out why it auto-aborted, right? You got to in Firefly's case, they got to figure out why they had that overpressurization event. And they, then they got, And in the meantime, they got the vehicle back into a safe state, so they got it in pretty much the configuration that they started with, right? And now you got to figure out why that overpressure event happened. You don't want to do it again, because if you just do the same thing again, it'll pop, right? It'll pop the pressure valves like what it did on the first attempt. So now they got to figure out why it did that. And that's the other reason why it's going to take a second. Didn't they launch like 2 weeks ago? 2 weeks for a second test flight is really good, isn't it? Firefly launched a couple of years ago, Sebi, and the rocket blew up. With rockets, guys, it's all about configurations. You got to config. You got to config the rocket. You put the rocket into a good configuration, and then you hit run program, so to speak. If the program throws a syntax error, you got to figure out why. Yeah, you're not just going to run the damn program again because you know it's going to break again. So that's why holds can take indefinite periods of time.
This is a really good question here. This is a fun one from Game Terminator 82. Is there a difference in speed you need to be going if you're going against Earth rotation or with Earth's rotation to get into orbit? Really good question. So the difference is the actual end velocity, the relative velocity that the spacecraft is traveling in relation to just the Earth will be the same. The actual orbital velocity is the same. But you don't get to take into effect the fact that the Earth is moving at almost 1,000 miles an hour, 1,600 kilometers an hour ish. That's a real rough guess. The Earth is rotating, so that inertia is actually, when you're launching up, it's slinging it a little bit, right? Actually a decent amount. It's slinging it a real decent amount. So if you're flying east along with the rotation of the Earth, the closer you are to the equator, the more that inertia you're getting. So if you're flying east, you get that sling. If you're flying west, you have to fight that sling. So you actually have to add a decent amount of delta V to counteract the rotation of the Earth. So again, it is actually technically harder, and you reduce your...
It's about 500 meters a second extra delta V if you're launching at the equator. If you're launching from somewhere like Kennedy Space Center or Vandenberg and trying to go retrograde, like straight retrograde, it's about 300 meters a second extra delta V. You have to negate the rotational forces from the Earth. Now, keep in mind, fellas, Earth is a non-uniform sphere. It bulges at the center around the equator, which is why, if it was a uniform sphere, you'd have the same speed everywhere, right? But it slightly bulges at the center, so that's why it's 500 meters a second if you try to launch like from Kourou. You try to launch retrograde from Kourou in French Guiana. It's a 500 meters a second penalty if you try to launch retrograde out of there. Now, simultaneously, you go prograde, so you launch due east out of Kourou, you get a 500 meter a second gain. But yeah, Tim's right there too. Orbital velocity stays the same. Long story short, the Earth's spinning this way. You have to negate that imparted velocity from launch, and you have to counteract the force of the spinning, and then you have to get into orbit right after that. The interesting thing is, the same case is true for polar, but polar is a little bit different. The worst place to launch into a polar orbit is somewhere near the equator, believe it or not. Yeah, why? Because now you're not going directly with or directly against that spinning rotation. You're going perpendicular to it, which, yeah, that's a little tough to do because you're trying to negate a spinning force going left to right and you're going forward and back. Well, in this particular case, north-south, and you're trying to negate an imparted force on the east-west on the lateral axis of the vehicle. This is why polar orbits, when they launch, they appear to do kind of a dog leg to the left. So on an ascent for a polar orbit, you want your launch site to be close to the poles. You want your launch site to be close to the north and south pole because that's where you're spinning the less, because non-uniform sphere, right? So polar launch sites you ideally want are ideally good for polar orbits. I know. It's kind of like it's in the name or something. All right, King.
And with this particular vehicle, they were able to do it on the first time. So as far as like being a fresh system, it's a lot more ready to go. And these vehicles obviously are able to handle the weather. I don't know if there's like a lifespan. I don't have any numbers on me about.
So then theoretically, launching from a pole, be the best way to launch. Launching from a geographic pole would be the best for getting into a polar orbit. Yes, that would be the least amount of delta V. Yes.
They can take this thing. The cool thing is, so many times they work on the rocket literally just like within minutes. They can lay it down horizontally. I've been out there on the pad when they're taking it from vertical to horizontal, and just so cool seeing a team just be able to work on something so routinely, just so simply and easily, and they just go, oh, okay, we're just, open up this cover and you'll just see them working on stuff like it's nothing.
That's Astro.
That is
rocket.
kind of the difference between some of the new space mentalities versus some of the more traditional aerospace mentalities. Is just and the size. This is a lot smaller.
I know you speculated about
like
the hold
SLS.
already. They had an overpressure event in 2 spots, Alex. There was something up there on the TE did that.
We're seeing some more venting, but I have not heard any word yet on.
Hold on.
I actually just did get an update that we're expecting a new T0 time.
So that's a depress vent.
To keep in mind, when you're flying a rocket, some of the things that matter for T0 is actually range considerations, like where the rocket's going to go, where the payload's going to go.
No, they had an overpressure event on the transporter erector, and it popped off a little bit of gas like that and went psst, right? And then something down here, a check valve, I think is what it is, on the top of the RP-1 tank shot out some condensation for a second and went psst. Sounded like a whoopee cushion. So, fellas, that was LOX. If you see the streakiness, some liquid came out of that nozzle.
That's awesome. So stand
that
by.
was a depress vent, but I'm not sure what it was a depress vent for. So, Alex, my guess is that they had some anti-geysering going on because they didn't get the LOX replenish rate right into the second stage tank, but that still doesn't explain why whatever the vent was down there, why that thing went too. I don't know why you'd have a vent down there. That's at the top of the RP-1 tank, so the liquid fuel tank, which is non-cryogenic. You can tell it's not cryogenic because of the way it is. No, there's not ice accumulation. What happens when you have a cryogenic tank? So basically, liquid oxygen is really friggin' cold, like really cold, like colder than liquid nitrogen. Remember the Terminator? Hasta la vista, right? Like, yeah, I know. It's late. Give me a break, okay? So what happens when you have cryogenic tanks on rockets is that the tank gets so ridiculously cold that ambient moisture in the atmosphere, when it gets near the tank, actually basically freezes, and ice forms on the outside of the tank. So you can basically tell where the liquid oxygen tank is because it's a big chunk of ice. And then the upper stage liquid oxygen tank up there is also that band up there, also a big chunk of ice. So that means the RP-1 tank is right here, and then the inner stage is right there, and then the first stage RP-1 tank is down here. The vent came from just on the top of the RP-1 tank. Now, if it's something that I do know about rockets, you don't fill liquid from the top of the tank. You don't pour the propellants into the tank. That's not a good idea. Splashing around highly explosive liquids doesn't seem like a good idea. They fill from the bottom. So tanks are usually filled from the bottom, and they fill them up that way. And what usually is at the top of any particular type of tank is venting. So a pneumatic line, a vent line. You wouldn't have, at the bottom of the LOX tank, what if it was a bleed valve? I don't know why you would put a bleed valve there, Alex, unless this thing does something that I'm not particularly familiar with. You generally don't want to bleed right there, because if you bleed right there, it's just going to shoot liquid out because you're at the bottom of the LOX tank. Archimedes' principle will do its thing. So you generally want to bleed from the top. And it looked like an RP-1 tank depress. Now, the RP-1 tank does get pressurized to an extent. So, yeah, it's super interesting. I'm not sure how they were correlated. It could have been an anti-geysering event. But, yeah, I don't know what the hold was here. Not a pressure bleed, a propellant bleed. Well, that means it would be shooting diesel fuel out the side.
Company, Northrop Grumman, who is launching to the International Space Station for NASA for the cargo resupply missions.
Give me 1 second, dudes.
They'll be launching that baby and have a brand new first stage with the Northrop Grumman's upper stages on it. So no more, the Antares rocket currently uses Ukrainian tanks and And then
So I'm doing a test.
Russian-derived.
I'm doing a
well,
test
they
in here.
were using originally the actually remade NK33 engines, which became the AJ26, but it was basically more or less.
I'm doing a test in here, fellas. Temperature test in the office right now. I do have a little tiny space heater over there, and I have to say that the space heater is doing a good job. It's 80 degrees in here, and I'm sweating. So what I did was I opened the door to the garage because it is really hot in here.
In Luna, but we do have a new T0 time.
Yeah, so it looks like the insulation that I put in my office might be a little bit of overkill, but that's not a bad problem to have.
That's only about 24 minutes away, so yeah, yeah, that's great. And there will be another poll. That's going to be great, though. Okay, so coming up here before the top of the hour even. Let's see here.
Rev, what did you say? My guess was a vent or relief valve for the RP1 tank that could have vented off when a abort was called. Yeah, Rev, from where the TE vented and whatnot, and the location of the TE event, it looks like an anti-geysering event. I'd say anti-geyser. I don't think they got their LOX replenish rate correct, and too much oxygen, too much gaseous oxygen built up in the line. They had too much GOX, and the thing literally popped. It went, psst, you know. When you hear the psst like that, yes, I like making that noise. Okay, when you hear that, that means a vent from high pressure, right? Because if it wasn't a vent from high pressure, it'd be like, you know, not anti-geysering. Geysering event. Anti-geysering is something that you do with a rocket when you slow the fill rate to prevent overpressurization in the LOX line. Orlan, thank you for doing a long stream to cover the launch. My pleasure.
And Allie,
your humidity is 36. How does it get for it to start? How low does it get for it to start bothering you? Yeah, it's 35. Yeah, that actually is super low. It's not bothering me right now. No, low humidity doesn't bother me. I'd have to say, like, probably, I don't know, if I had to take a guess, 10. I've never ran that low a humidity in here.
And hopefully all we get goes across the board again.
Okay, we got a new T0.
So that'll be awesome. All right, back to that beautiful rocket. Don't want to take my eyes off that thing. I love it. I love how icy it is, too, by the way. It's just so cool to me that compared to, remember, the other launch attempt, because it was the daytime, you just really didn't see the ice on it. And now you really see the ice on it, especially when it is this chilly. All right, here, so glad to see that Bob Vila, maybe the famous house builder Bob Vila, maybe, says margarita pizzas are the best. If Bob Vila says it.
Bob Vila sucks. Steve Thomas and Norm Abrams. That's this old house. Bob Vila's this old house. Give me a friggin' break.
Crews need to go out to the rocket. What are the safety protocols to do it safely? So humans won't be within the a rocket when it's fueled up. Helium on board. So don't forget, a lot of rockets have.
What'd you say, Rev? That's what the release valves do. They pretty much a blow-off valve set at a certain pressure. So they got check valves in the system. All right, cool. So we were pretty much spot on. That's good. Although usually relief valves tend to be ground side, not flight side. Well, one of them was ground side, but yeah, the RP1 tank. I've never seen an RP1 tank vent before. That was strange.
Those other tanks. There's also oftentimes some rockets will have nitrogen. This rocket also has T-tab, so triethyl aluminum, triethyl borane to light the engines, and especially the lightning engine needs its own ignition source. So there's a handful of just other systems on board that are under pressure.
Mike Holmes better than Bob Vila. I'm with you on that one. Yeah, I like Mike Holmes. He's a good dude.
To be out at a near a rocket while it's like this. But then again, don't forget that happens. Like, and as a matter of fact, it still happens today. When you think about the Atlas V and Boeing, when they go for their crew test flight, that Atlas V will be fueled up and just in a safe state. But people will be going out there on the pad, putting astronauts on board when it's fueled, and that's how they did it with the space shuttle. That's how they did it with the Saturn V.
So they're going to do it with SLS.
It's fairly normal, but it is a risky thing. And actually, SpaceX is actually backwards because they do what they call load and go. So they'll put the astronauts on board, get all the personnel clear, and then load the rocket up and pressurize the rocket. And to me, that actually makes a good amount of sense. And it's kind of the same procedures, teams like this with Firefly and their Alpha rocket, it's pretty normal that once it's...
So I'm gonna build off Timmy again here. Guys, rockets are pretty safe when they're fully fueled. So just to put that out there, they're pretty damn safe. I'd stand next to a fully fueled rocket, not when it goes off. That would suck. Rockets are they're in a pretty safe configuration when they're fully fueled, when they're in replenish mode. Even Hydrolox rockets. Now, here's the thing. SpaceX loads their propellant. They do a prop load while people are on board the spacecraft. The worst time to be near a rocket is when you're fueling it. Fueling is dangerous. The process of fueling is very dangerous because, let's look at SLS, for instance. You have hydrogen leaks. Don't want to inhale that. That would be not good for you. The scavenging system picks up the hydrogen leak, but there's a bunch of hazardous gases floating around on the pad. You're changing a lot of configurations on the vehicle all at once. You're starting to flow this propellant. You're getting pneumatic pressure buildup. You have to have an anti-geysering system. You're changing all this stuff. You're changing the pressures inside of the tank. You're changing the temperatures inside of the tanks. The tank is going to go through thermal contraction because you're cooling down the entire vehicle, right? You're changing a lot of things all at once. That's the most dangerous time to be standing near a rocket when it's on the pad, other than it going off, right? Standing next to a fully fueled rocket, pretty damn safe. Pretty safe. That's why they did it for 30 years with the space shuttle, and they're going to do it again with SLS. They fuel it first, and then they put people on it later. SpaceX does the opposite of that because they want to get more performance out of their liquid oxygen. So what SpaceX does, just in case their fueling procedure takes a dump, they arm the launch escape system on Dragon before they start fueling. And if something goes bad, it ejects the entire capsule. That's never happened, and hopefully it never does, but it could. That's how SpaceX compensates for the added risk of going through what's called transients when you fill a rocket up. Changing a lot of things on the vehicle all at once. Remember, you're changing the molecular configuration of atoms on the vehicle when you fill it with propellant. It's going to contract, and when it contracts, the structure changes. You're literally changing the configuration of the vehicle. You're changing the whole thing. It's a go so far. Privetchina. Как дела?
Figure it out. But I have a video called "Why Do Cylindrical Rockets Roll?" Because you'll notice this rocket has really almost no defined...
So, but you got to remember, in the context of that question that Timmy was talking about, okay, another depress vent out of the TE. You got to remember the context of the question that Timmy was answering. Tim was answering a question about, at what point is it safe to go towards the rocket? I wouldn't go towards this rocket right now. Not when an auto sequence initiation is going to start soon. I would not go near it. This vehicle could be pretty okay to get near. It should be fine. But should be fine doesn't really work with rocket science. If Firefly needed, for whatever reason, to get back out to the pad and start servicing the vehicle right there, they got to change something, got to swap out a part or whatever, I would make sure the vehicle is fully purged in what's called inerted. So no liquid oxygen in there, let it boil off, vent it out, drain the RP1 back into the ground side fuel tanks, and then fill the tanks with nitrogen or helium. Fill the tanks with an inert gas. Inert the vehicle. Put it in a prior known safe configuration before people even get near it. You don't want to roll the dice like that.
Atmosphere, but you pitch over to gain horizontal velocity in order to get into orbital speeds. You'll have to gain horizontal velocity. So you have to get going really, really fast. It's, about 27,000 kilometers an hour, 17,500 miles an hour. You have to go really fast just to get into orbit. So you go up, and then you'll get out of the atmosphere because the atmosphere can slow you back down. So you'll get up out of the atmosphere, and you'll just start to pitch over, and you'll just speed up, and eventually you'll be going so fast that you basically are falling, but always missing the horizon, which is really cool.
His producer is in the van from Cosmic
But yeah, to make it really, really simple, there's all these different inclinations. So imagine, the Earth and like a hula hoop around it, the International Space...
I'm telling you, man, there's a geysering event. They didn't get the LOX replenished flow rate correct, and too much gas built up and it overpressurized. It's a geysering event. That happens with liquid oxygen. That happens with liquid hydrogen. It happens with methane. It happens with everything. Any cryogenic propellant, that's what it does. If you don't get the flow rate right, you're going to evaporate too much propellant inside of the fill lines, and it'll create bubbles inside. It'll create bubbles inside of the propellant. The propellant, like think about it like if you have a soft drink and it's carbonated, right? You have it in a bottle. What happens if you shake it up and you twist it? You're making a lot more bubbles by shaking it up, and it pressurizes the bottle. The bottle gets harder to track as you increase the pressure inside. Literally that, but with rocket fuel. You do not want that to happen. There's a reason why every rocket has an anti-geysering step. They adjust the flow rates of the liquid oxygen so they don't evap too much propellant and don't overpressurize the lines.
The last one, so the only thing I know from their first launch was the first rocket they built, it took about 18 fills just to light the engines for the first time on the first stage. Not all the other times after that, because they probably did more than one engine ignition. I know for a fact they did more than one engine ignition. But the first time it took them 18 fuel up operations just to be able to do a successful...
Portable Jim, before Blue Origin's abort, when was the last time an abort system fired outside of a test? 1985. A Soyuz caught fire on the pad in the Soviet Union at Baikonur, and it ejected the Soyuz capsule off. Crew survived. Actually, 1985 was an on-pad, a pad abort. The last in-flight abort was MS-10. Excuse me. Sorry, I had to remember. It's getting late. The Soyuz MS-10 mission with Nick Hague and Alexei Ovchinin encountered a staging anomaly going from first to second stage. Basically, one of the side boosters tried to pop off, and it didn't pop off, and it came back and slammed the second stage to the center core and broke it. And then the capsule ejected on the RDG traction motors, which is not technically part of the Polar launch escape system. It's a secondary traction motor just there in case like after the launch escape system ejects. Oh, big vent down.
Let's see.
So
well, thank
MS-10,
you very much again to Ted's Fix It Tech.
MS-10 a couple of years ago, and then 1985 a Soyuz had a pad abort, and that's it.
Question. Launch Recap wants to know how many...
That New Shepard flight, if you watch that live with me, that's the third time in history an operational mission has had an abort. In history. Crazy, right?
Still a work in progress. I know we have a lot of people wanting us to do a wrap and things like that. It'll get a nice fresh coat of paint once everything's done, but that's low priority.
Something guys, something broke. Something's wrong with this. Yeah, they've done a lot of vent downs very, very quickly, and some of them was venting so much liquid oxygen that you could literally see it before it turned into a gas. That's what those streaks are.
8K.
My gut's telling me something's broken, but then again, I don't know. I'm just some guy.
4K feeds, but we don't have it wired up that way.
By the way, Starship doesn't have an abort system where they fuel it with crew on or off. I have no idea, Revril.
So, like I said, it's still a little bit of a work in progress, but I'm getting confirmation of yes, it is.
Wasn't there an abort to orbit? The shuttle, yeah, STS-51F had I think it was 51F had an abort in 1985. Challenger had an abort to orbit, yeah. But there was, I'm talking about like launch escape system, jettison the capsule, not a shuttle abort. You know what I mean?
Just need to know which Arvin needs. Yes, the pointy end is still up, and the flamey end, oh, there it is. Flamey end is down. Look at those Reaver engines. You can see them chilling down there. They are running propellant through them to begin to chill them down. One of the big things, believe it or not, you'd think the heat of lighting a rocket engine is the thing that'd be so damaging or hard on the engines, but actually, it's actually the cold that's almost harder on them. You know, liquid oxygen flowing through those pumps can be really hard on the bearings and things like that in the turbopump system. So they'll actually start to pre-flow and run some of that liquid oxygen through the rocket, through the engines, just to get them thermally conditioned. Because once those engines are running, let me tell you, there's a lot of fuel flowing through there, a lot of opportunity to get really, really, really cold. So yeah, that's what the liquid oxygen is And when they chill it down, that's kind of what they're doing. And in this case, sometimes you can use your fuel or your oxidizer depending on which propellants you're using. When you're using RP1, you don't necessarily want to, RP1's not going to cool it off that much because it's more or less room temperature. So, yeah.
Yeah, that's all right. Tim knows his stuff, dude.
Yes. Do we know what caused the first Firefly rocket to fail? Absolutely, yeah, of course. They wouldn't be flying. They definitely wouldn't be flying again if they didn't know, if they hadn't tracked down the root cause. And believe it or not, it was a simple connector. E3, engine number 3, happened to fail on ascent. A lot of it might have been because, again, I mentioned how many times they had, played with that rocket and how they used that first rocket to, you have to develop everything for the first time with their first rocket. So that rocket went through a lot more, and they found out that there's an engine connector with this, kind of fancy plug that powers the, it does a lot of things for the engine, but basically more or less powers, physically runs voltage to the engines to open the valves and things like that. And that was sitting in a relatively higher vibration environment than they probably wanted and preferred. So literally the solution was just to move that plug further upstream and just run a little bit longer. Basically when you have 2 wires and you have a plug there, you can just change where that plug is in relation to those wires. So they moved it out of a high vibration environment, and they're seeing about 1/10 the amount of vibrations. And then of course, again, the rocket, is also
revert to valve.
Been cycled a lot less and
get it right.
has a lot less wear and tear. So they're quite confident that that's going to definitely has solved, and they knew that almost immediately. They knew it upon recovering the vehicle. They saw that the engines had been disconnected from that one engine. E3 had been disconnected, and Tom Marcusick talked about that. And if you haven't watched that video, guys, I swear that's one of my favorite interviews of all time. Is going through Firefly's their development place at Briggs, Texas, with them, with Tom Marcusick. He answers some questions that I have been wanting to know the answer to for so long. He's really, really just a brilliant man. So hearing from him on some of these things was just awesome. Definitely watch that video.
Tim.
You'll have a bigger appreciation for some of the engineering involved. So, all right, we do have comms back on, so hopefully we'll be hearing from them.
Did you ask if we were live?
And then we'll hopefully hear from them, and we'll be able to get some updates. All right.
And
so yeah, this is from QWERTY asking, a few minutes ago you mentioned recycling and refueling. Why would it have to be refueled? Can't they? So they basically keep it fueled up, but the difference is they're just basically venting out and repressurizing and recompressing and getting all of the RP1 back up to flight pressures, and also resetting the locks and getting the, so you have to recycle some of the locks in there, the liquid oxygen, and get that back up to operating temperatures as well. So although you say refueling, it's not necessarily like they're draining all of it and then refilling completely from standstill. It's more or less, especially like you said, the fuel, RP1 more or less just is ready to go.
20 fuel prepress has begun.
Okay. Fuel prepress, so they're basically getting the RP1 tanks up to...
Fuel prepress has begun, that's what we heard, so they're getting ready to pressurize the fuel.
T-minus 8 minutes.
What he said.
All right, we have cameras at the pad rolling, and are our cameras good to go here again, too?
Nice, Blue, that's cool.
Sweet.
Mossy, been a while since I've been around. Glad to witness
Kai.
a launch
Hey,
like this
Kai,
here.
how you
Right
doing?
on, dude.
From Garden Grove, California. Question:
Kai
When is the
win.
next video getting uploaded to YouTube? Not live stream. We're waiting for the jet video. Yes, that's what I'm currently editing right now. Last week, this time, a little bit more than a week ago now, I was.
It's a 2-hour
out
window.
in Bozeman, Montana, riding in a fighter jet, doing some
T-minus 7:30.
some fighter jet training with the Polaris Dawn crew. It was awesome. Can't wait to share that video with you guys. I mean, just the experience was amazing, but also I did some history on fighter jet training, why NASA still does it today, why commercial crew is doing it, like Jared's crews are doing fighter jet training. Very, very cool. Really fun video.
Nah,
Hopefully you guys
you'd want to put it in. You'd want to test as you fly. Put it in a
Do
flight
it.
configuration, regardless of payload.
Let's see here.
T-minus 7 minutes, we will have S2 TVC wiggle check.
Stage 2 thrust vector
that's
control.
Stage 2. They're going to be just double checking that the Stage 2 TVC thrust vector control is able to steer and wiggle. So that makes sure that.
Please confirm there's no warning.
Sounds like they're good to go on Stage 2 steering. That's a good thing. You need to be able to still steer with your second stage.
Stage 2 guidance officer says no warnings indicated from the Stage 2 thrust vector control test.
Juan in our Discord wants to know, speaking of working fluids, does the Alpha use cold gas thrusters for the RCS? Actually, I think
T-minus
so.
6 minutes and 30 seconds. FSW, please start a wire shark capture on umbilical port PCAP server.
Complete.
Flight data recorders, I think.
Probably important, though.
T-minus 6 minutes, 10 seconds. The vehicle's on internal power.
So Alpha is once again cut off from the grid.
So pretty soon we're going to be able to see the strong back retracting again. We'll see that claw open up, and you'll see the strong back recline just a little bit here. But that's coming up. Oh, there we go. There's the claw opening up. The claw. There you go. And soon we'll see the strong back action.
No. No.
Again, thank you, Firefly, for letting.
Strong back is moving into the retracted position. You can see the umbilical wires there for pulling the umbilicals. Those are usually on a pulley with a counterweight. When the rocket goes, they let the counterweight drop and it pulls the umbilicals away from the vehicle when it launches.
Just clear here. That's important.
See all
Make sure
the, all the slide wires for all the
flight
umbilicals up there?
path of the rocket. Sammy, I hope that we see a launch out here and that we see the sky light up from a new launch vehicle. This is, again, an exciting demonstration mission, a test flight. The second Alpha rocket from Firefly. So things are looking good here. We're coming up on T-minus 4 minutes. Really, fingers crossed for the team. Everyone in chat, wish them luck. We're getting really close here, and you know, obviously this is an exciting moment for the teams at Firefly.
And Bill used gravity.
Wish them luck, and again, thank them for allowing us to be able to provide coverage like this for you guys in 4K. You can see the teams there. I bet everyone's heart's racing. My heart's racing already.
T-minus 4 minutes. FTS, please confirm FTRs are active and the range is transmitting check channel 4.
FTRs are showing check channel.
FTS, please send ARM enable 1 command to all ESADs.
Flight data recorders and flight termination system.
FTS, please send ARM enable 2 command to all ESADs.
ARM 2 sent.
FTS, please confirm that all ESADs are enabled.
All ESADs are enabled.
Sensors
FTS,
for the flight
please
termination
save all ARM
system.
commands.
ARM commands are saved. Fly safe.
Thanks, FTS.
Okay, we're further in the count than we got before.
That's awesome. So, yep, flight termination systems are armed. We're coming up on T-minus 3 minutes, and all systems are go. So hopefully we actually, you know, it's looking good. The vehicle's really iced over now. That one band that is on the liquid oxygen tank there on the first stage is almost entirely ice as well. She is ready to go.
T-minus 3 minutes. Fuel bleed is beginning.
Thermal conditioning.
There'll be a go, no-go at T-minus 2 minutes. Any no-go at this time will be an automatic abort.
We have everything recording?
It's good, Alex. They're beginning fuel bleed on the Reaver engines. So
all right, all pad
to
cameras are
move
going.
Liquid oxygen into the engines to chill them down.
Oh, it's so exciting.
It
never gets old,
It basically
honestly.
primes the engines.
Even, you know, Ryan's seen more launches than I have, and I've seen a handful. I mean, I've seen a couple dozen or a few dozen.
T-minus 2 minutes and 30 seconds.
When you get this close,
disabled.
it sure is exciting. So for us, we're going to see it coming up hopefully over the mountain. We get a little clearing before we lose it to the clouds. But again, we do have tracking cameras that'll be able to track the rocket.
This is prop, confirming good fuel bleed.
Confirmed prop.
The propellant officer
Coming up on T-minus 2 minutes.
reporting good priming of the rocket engines.
This is the final commit for launch. Chief Engineer.
Send it.
Launch Director.
Go for launch.
Word.
Rock. Thank you, range. Flying step 12.20. We are go for launch.
Send it. That's what we want to hear. The teams at Firefly are totally go. We're coming up. We're under T-minus 2 minutes. I'm excited. I am so excited. All good. Everything's recording. We're good here. We're really hoping to see this baby lift off today. And again, friendly reminder, this is a demonstration. This is a test flight.
T-minus 90 seconds.
And they're just hoping to really check off a few new milestones here for the teams. So we're going to just be cheering them on the whole way. Whatever happens today, guys, just positive vibes and Let's hopefully we get to see a new rocket make it into orbit today. This is really, really exciting. Man, my heart's racing.
We heard some pneumatic valves open and close there, but they had a close-up shot of the fairing, so I didn't know where
T-minus 1 minute.
I don't know where they came from. Counter still goes, so I'd assume that's just
Alpha transitions to autonomous mode.
Copy.
Zuna.
Lock sync is pressed. T-minus 45 seconds.
Oh, look at that engine cam.
See, the engines are bled. See, look at all of that. Look at all the locks coming out.
T-minus 30
Gocks
seconds.
coming out of there.
BC, please confirm we're on autonomous mode.
Internal count state.
Thank you. T-minus 23 seconds.
Thrust vector control checkout on the first stage.
T-minus 20.
TVC checkout is
Here we
good.
go.
15 seconds.
T-minus 15. T-minus
10.
10.
5 seconds.
T-minus 5. 4.
Stand by for engine ignition.
3.
Triumph ignition.
1.
Bent. No, abort. Nope.
Oh,
nope.
abort.
Vehicle
Nope.
abort.
Nope.
Safing the vehicle.
Oh man.
Tanks depressed.
So,
They had another
no.
overpressurization event. So you saw a green flash. The green flash is normal. That's a pyrophoric ignition fluid called triethyl aluminum and triethyl borane. They use them to start spinning the turbines on the rocket motor to get the turbine spooled up to be able to pump the adequate amount of fuel in RP1 into the rocket engine. The green flash basically means that's like cranking over the rocket engine. We did see the green flash. Now, if you're wondering what triethyl aluminum and triethyl borane does, they're pyrophoric ignition fluids. When they fire them, and when T-tab combines, if it finds oxygen, it's going to explode. It's a chemical reaction. It just explodes, and that explosion is enough to spin the turbines on the rocket motor. The turbine on the rocket motor is attached to a fluid impeller. Turbine, impeller. Turbine, pump, turbo pump. Now, each one of those Reavers has a turbo pump on it, and there's actually 2 impellers in a turbine. One is for liquid fuel, the other's for liquid oxygen, right? They did get T-tab, but on ignition, the vehicle automatically entered a safe mode by depressing the tanks instantly. That could indicate a couple of different things. It could indicate a hard start on one of the Reaver engines. Maybe just something was out of family. Maybe one of the turbines didn't get spun up to the adequate amount of RPM. It could be a bunch of different things, guys. The rocket basically right after ignition went immediately into safe mode. How do you know so much about this? I'm a nerd, Nebula. Don't let anybody fool you. I'm a huge nerd. Yeah, I read, dude. I read a lot of books. Self-taught. I just freaking read about space every day. Yeah, it's fun. It's good stuff. I love it though. Thanks, man. Appreciate it. Yeah, no, I'm a nerd. Don't let anybody fool you. Yeah, big nerd.
Ryan will too. We're gonna get it is chilly, so I'm actually gonna wait until we have an update from Firefly.
Like pocket protector, thick rim glasses tier. Like that, it's that bad. No, I've been teaching myself this stuff over the course of about 10 years. Been streaming here about a decade on Twitch. Come December, I just keep reading, and I have people in the industry that help me learn and understand this stuff so I can communicate it better. Because it's freaking cool, dude. That's really cool. You're a nerd. Yeah, I don't know. How does it stop so quick right before launch? Depressing the tanks, bringing the tanks down from flight pressure, usually helps. Tony? Yeah. Are they out of T-tab? Now, that would be my concern. If these Reaver engines aren't really designed to be fired more than once, do they have enough? T-tab comes in cartridges. They come in cartridges, kind of like a CO2 cartridge almost. And you need, it's a radial cartridges, so it's a radial cartridge, so you need T over here and tab over here, and they need to shoot into each other so they atomize and mix, and then if they find oxygen, they'll explode. That's part of the reason why they bleed the engines with LOX. Do you see how much LOX was coming out of the nozzle there? It's a good reason for that. So it depends on how many cartridges they have loaded into those engines. My guess is that a company like this probably doesn't, but they might. Who knows? They could have some T-tab left in the cartridges. But yeah, the engines clearly want to start up, and usually when you get an abort like that, like right at engine ignition, that means that's indicative of hard starting. Hard starting is like if you had a car that was off and you put your foot to the floor on the gas pedal, and then you turn the ignition. Yeah, it might be fine, but it's probably not going to be fine. You're probably going to break something. Now, don't get me wrong. I don't know if this was a hard start. Honestly, the rocket is changing its configuration between T-5 and T+1 so ridiculously much that there's 1,000 things that it could be. I mean, I don't know. All I know is that right after the pyrophorics went off, it immediately registered an abort condition because the tank's depressed. The RP1 tank depressed, and the oxidizer tank depressed first and second stage. Hey, Logan. Can Falcon 9 do the same? Falcon 9 uses T-tab in the first and second stage, Tony. Yeah. Falcon 9 has multiple cartridges because the engines relight. But it only has multiple cartridges on some of the engines. The center 3 engines. So it's I think it's the E1, E8, and E9. Or no, it wouldn't be E1 and E8. E1 and E8 are too close to each other. It would be probably, I think it's E1, E5, and E9. So it's the 3 engines in the center on Falcon Heavy. Like there's engines up here, engines down here, and there's 3 in the center. The ones in the center that they need for the re-entry burn and the landing burn for the first stage have more cartridges loaded into them because they need to start multiple times. Now, Tony, I'm not familiar enough with Firefly systems to know if they have more T-tab in the cartridges there. So, I don't know. I don't know. If they have more T-tab, they probably have time for another attempt. There's still about an hour left in the launch window. But I don't know. It really depends because they had a T-tab ignition. They had a pyrophoric ignition. They only did a static fire test. Yeah, no problem, Tony. I'm going to go back and look at that ignition real quick.
Oh, man. 10.
Let's see. This is a
5,
replay?
4,
3,
1.
Oh, abort.
Vehicle abort. Saving the vehicle.
Oh.
Is it? Did you guys hear somebody curse under their breath there?
4,
3,
1. Ready?
Oh, abort.
Vehicle abort. Saving the vehicle.
Listen.
Oh, man.
Well then, somebody was mad. Yeah, Glex, right? Yep. Oh yeah, somebody said a bad word. Yeah, no, that's frustrating. I'm not gonna lie. It is frustrating as hell. Let's see it again. So it looks like they had a good T-tab, but we started to see a lot of flashing down here, and that could have been the engines just ramping down, guys. But yeah, they yeah, the computer saw something that it didn't like. It immediately vented the tanks. Let's watch it again. It is red. Yeah, that's right.
4, 3, 2, 1.
Oh, abort.
Vehicle abort.
I want to listen. Let's listen to the rocket.
-5, 4, 3, 2, 1.
Oh, abort.
Vehicle abort.
So those that thing made a weird noise, and I don't know if that's just these engines, but we definitely heard the hydraulic hammering that typically happens when you shut a rocket engine off. The honk. It sounds like a tractor trailer locking the brakes, like that noise. You definitely hear that, but I noticed that right before ignition, there was a high-pitched whistling before the rocket engines turned on. There was high-pitched whistling when the T-tab was on. Once again, not sure if that's the rocket motor, just conveying what I'm hearing.
-5, 4.
Like, listen, you'll hear a scream. Hear it? I talked over it. I gotta back up.
10.
At 3.
-5, 4, 3.
Hear that?
1.
Oh, abort.
Vehicle abort. Safe in the vehicle.
Oh, man.
Yeah, there was a squeal there. Now, I don't know much about Alpha, to be honest. I don't know. I don't know much. I don't know much about its systems. I'm not too incredibly familiar with it. However, I mean, that squeaking noise could be a bunch of different things. That squeaking noise could be the turbo pump spooling. That's what it sounds like. When turbo pumps spool up, they make a zzz noise. It sounds like an electric motor. It's not, but the RPMs are similar. So you hear the same kind of whirring sound. With that being said, the power pack shouldn't stay on like that for very long without the rocket engine going, or else you're just gonna shoot a bunch of unburned propellant into the flame trench. And we know from our buddies over at SpaceX with Booster 7 why it's not a good idea to spin start and dry fire a rocket engine like that, because Booster 7 had that little pop on the pad a little while ago. Yeah, you don't want to do that. It explodes. Now, once again, I don't know if that's what happened here. I'm kind of shooting in the dark, guys, because I'm not too familiar with the vehicle. If you really want to know, like, the real answer as to what's going on right now, well, you got to wait until the teams assess the data. Anything without analysis and numbers here, especially when you're, like, in a launch window ready to launch, anything without analysis and math or numbers to back it up is just speculation. It doesn't matter if it's coming from me. It doesn't matter if it's coming from the launch director. If they're kind of, I feel like the rocket's doing that. No, that's not a thing here. You have to prove what it did. Okay, you have to figure out. So in this case, they have to figure out why it aborted, what caused the system, and how. And they have to, as a mission director, you have to be able to think fast on your feet. So they have to troubleshoot on the fly, but you got to prove it with math. Think about it like trying to do calculus homework while you're in a combat zone. It's kind of like that. It's a very stressful environment. Here, do some math. It's like, okay. Check Bandit's link. You don't hear it on this. Let's hear it. Yeah. So that's, if you don't hear it there, here's the launch from a year ago. Alright, this is what you guys want me to see. Alright, so... let's listen. Yeah, I mean, a fuel line could have popped. Not a fuel line, but... Hang on. No, I don't think Firefly has human spaceflight on the roadmap, but they do have lunar landers, uncrewed, but still, that's pretty cool. Left side of the screen. No, it sounds like they had a overpressure event again. So if you're just tuning in, we're tuning in here to Firefly Aerospace's Alpha Flight 2, or FLTA-002. The name of the mission's up in the top left corner. This is a test flight for the Alpha booster. That's the Alpha booster right there. It's a 2-stage to orbit launch. GSE vent. Ground surface equipment venting. So that means two things. They either sprung a leak, or they're venting down the GSE tanks because they're done. It's Vandenberg. Firefly's not having a lot of luck tonight, guys. They're not having a lot of luck. They had an overpressure event at T-minus 4 minutes on the first launch attempt. And then the second launch attempt got to ignition. And when they got to ignition, the vehicle entered an abort mode and shut itself off. I just learned that Sophia retired. Shame. Yeah, they cut the budget for it, which is annoying. It was lucky because it didn't explode on the pad. Well, rockets have fail-safe systems to avoid that, and the check valves caught it on the first try. I honestly think that high pitch during engine ignition had something to do with it. Rockets generally don't do that. That could be an that could be the turbine. The turbines could be spinning too fast. That is a thing. Or some kind of overpressurization event could be going on. I mean, there's 1,000 things on a rocket motor that could, you know, if a pipe sprung a leak or they blew a freaking gasket, there's a lot of things that could be. But I think that high pitch noise is the root cause. Rockets generally don't make a really super high pitch noise like that. Generally, when a rocket engine starts up, you do hear the turbo pump spooling, but it's like zzz, not like a squeak noise. It's not like that. It sounds like you guys ever have a toy car and you pull the toy car back and then you let it go and you pick it up and the spring unwinds and the wheel spin and it goes zzz.
I have some hot chocolate. I am warming up here, but as you can probably see and hear, the rocket is detanking, and they are completely resetting. So this was an auto abort that was built into the system, of course, for ultimate safety. You know, obviously these rockets have more sensors than any one human could ever keep track of. So the computer saw something it didn't love, and it auto aborted. So they're actually going to be completely scrubbing for tonight.
Yeah.
They're going to look at their data tonight, figure out if they know for sure what's going on, make sure everything's totally thumbs up. As you can tell, they're detanking the rocket. Everything's looking good now, though.
Damn.
They're going to be looking at the exact same launch window for tomorrow. So be sure you're staying tuned to Firefly's Twitter, to my Twitter as well. Firefly, of course, at Firefly Aerospace. You'll find me on Twitter just by searching Everyday Astronaut. We'll hopefully give you guys an update as soon as we for sure have confirmation that tomorrow is go, assuming everything is going swell tonight for the rest of the night as they continue detanking operations. You'll notice literally quite that right now. You do see all that extra condensation out there right now. So the rocket is safe.
Damn it. All right, I'll see you guys in 24 hours. No, can we do the start time like at 2 tomorrow or something? Yeah. Well, looks like we're just gonna have to do the same thing tomorrow. Just keep going, man up. Yeah, I'm leaving. Yeah, I'm leaving. I'm leaving right now. Yeah, they did scrub. They vented down the tanks. That's a dead giveaway. They had something went wrong at T-1. Something went wrong with engine start. Once again, guys, you got to think about it like this. The more things that you're changing on the rocket at once, the more likely something is going to go wrong. So engine start is when the rocket's going through a crazy amount of transients. Once again, you're changing the pressures inside of the tanks. You're changing a lot of temperatures on the rocket engine. Turbine side of the rocket is getting really cold while the nozzle is getting really, really freaking hot. This all happens like that. You shock heat parts of the rocket and it can break things. It can break things. That's what happens. So Tim's going to log out here. That was great coverage from him. Guys, be sure to go give him a sub on YouTube. Everyday Astronaut. Excellent STEM educator, dude. Yeah. It's one of the few people that I would actually be like, go watch him. Like, he's damn good at what he does. Go over there and give him a sub. Believe me, his commentary was great tonight. He did a good job. Scrubs happen. It is what it is. Yeah, so go over there and shoot him a subscribe if you could. I will see you guys in, I don't know. I'm going to try to aim for 12, but that's probably not going to happen. So if I'm not here at noontime, we'll just say 4 o'clock and we'll do space news right off the bat. We'll do space news to racing to launch coverage tomorrow. You're doing great. Always a pleasure listening to the launch commentary. Thanks, Rocket Scientist. I appreciate it. Definitely a great channel. Learned a lot from his channel as well. Tim's the real deal, dude. He's a good dude. He's a good dude. Anyway, yeah, guys. So, yeah, unfortunately we had a scrub. That does suck, but people forget about scrubs. People remember if the thing blows up on the pad. Oh, yeah, people remember that. Oh, yeah. So, I'll see you guys tomorrow. If I'm not here at noontime, I'm going to be here at, if I'm not here at noontime, I'll see you guys at 4. Okay? So, thank you very much for watching, everybody. I hope you enjoyed the coverage. Once again, go subscribe to Tim. And Firefly Aerospace's YouTube channel's out there, too. That's what Tim was broadcasting on. Make sure you support our fellow STEM educators out there, okay? Thanks for watching, everybody. I hope you enjoyed the marathon stream, and I'll see you guys tomorrow. Or today. Have a good night.